Good morning and welcome everyone to Kaggle CareerCon 2019. My name is Addison Howard. I am a program manager on the Kaggle competitions team, and thank you for being a part of CareerCon with us this week.
I am Jessica Lee, a data scientist at Kaggle. We will be your co-hosts over the next 3 days for this entirely virtual event. We are very excited to be here with all of you as you learn how to build skills, get noticed, and get your first data science job. A couple of housekeeping items before we begin. Videos will not be posted online immediately following the event. They may be posted in the future, but please be sure to tune in each day live so you don't miss out on anything. Also, if you haven't already, make sure you join our Slack community channel so you can get to meet the rest of the community, ask live Q&A questions to the speakers, and participate in the digital career fair on the last day. You can join the Slack channel by clicking on the link below the video in the description. You will also find a link there to the CareerCon website, which has the full schedule and details.
All right, now that we have a couple of those logistics out of the way, get ready for 3 days of informative content, intriguing conversations, and practical insights on how to land your first data science job. Not only do we have a schedule for you packed with valuable seminars and engaging panel discussions, but we also have practical workshops to help you stand out in the recruiting process. But before we get into more details of the week, let's see how each one of us got here with some data that we gathered from tens of thousands of data scientists.
We asked data scientists to tell us the origins of their data science education background. The most common learning path? You taught yourselves. You might be surprised to find that formal university education didn't even make the top 3.
So this is just to say, no matter your path to becoming a data scientist, you're in the right place and you're not alone.
Data science is also a rapidly growing job market, and your skills are in higher demand than ever. According to the US Bureau of Labor Statistics, in the next 7 years, there will be 11.5 million new jobs in the data science and analytics space. Kaggle CareerCon is all about sharing practical advice to help you land that first data science job.
So here's a brief overview over the next 3 days. To start off, we'll have seminars and panels from expert data scientists, hiring managers, and industry professionals from various fields. And each day has its own theme. Today, for example, the theme is all about building your skills. What skills should you learn? How should you delve into data science given your current background? Tomorrow's theme will be on getting noticed, and Thursday's theme is all about getting the job.
We also have a couple great events happening in Slack, so be sure to join our CareerCon Slack channel. Today, we'll have a digital job search mixer at the end of the day for you to meet one another and share your stories.
So we'll be back in just a minute with our very first session of day 1, which is a part of our API building workshop. So take a deep breath, fill up that cup of coffee, and settle in for a full day of data science. We'll see you soon.
I'm excited to kick off our first session of the day here with Kaggle's very own data scientist, Dr. Rachel Tatman. It's difficult to get experience deploying models before you actually have a job. Stand out by joining Rachel's workshop every day on building and deploying your own API, a great resume builder for potential recruiters. Rachel earned her PhD degree in linguistics from the University of Washington. Her personal research is on computational sociolinguistics, aka how our social identity affects the way we use language in computational contexts. She's an expert on all things NLP and has great perspective on what skills you need in a data scientist job today. Take it away, Rachel.
Let me try that with mute off. Good morning, everybody, or evening. I know some of you are out in the different time zones. So this is a 3-day event. If you miss one day, all the notebooks are public. You can go back and check some of the other days. And on day 1, we are going to talk about designing APIs, and then we're going to design an API. And then on day 2, we'll actually sit down and write our application using Flask and Python. And this is going to be all in Python. And if you're interested in using R, a lot of the same fundamental principles will apply. Day 1 would be exactly the same for you. For day 2, you could use something like Plumber, which is an API library for R. And then on day 3, we're going to actually deploy our APIs that we've built. And you have a choice here. You can either use Heroku or Google Cloud. We'll be using App Engine on Google Cloud. For both of these services, you're going to need an account, and we'll mention this and send you a reminder. If you're going to use Google Cloud, you do need to set up a billing. I don't expect you should get charged, but they do require that you have a credit card to set up a billing account to build an app, and that's an abuse prevention measure. And I know some folks don't have access to credit cards, so if that's you, we'll also talk about Heroku. We'll probably talk about Heroku first as well. All right, today I'm going to talk for some time about what a REST API is and the parts that make it up, and then how you would talk about and describe what's in your specific REST API. And then I'm going to, I have an existing little specification, and I'm going to edit it and add some things so you can see how that would work. And then finally, I'm going to head over to the Slack and answer questions. And I'm not going to take questions during the first portion, because what I've learned is that if I see a question, I will answer a question. And there were a lot of folks last time I did a live stream like this that were like, I would appreciate if the questions were at the end, so I could choose whether or not to stick around for them. All right, so REST APIs. The first question you might have is, why would you want to build an API in the first place? So I wouldn't really consider this a core part of a data science job. And of course, data science positions vary wildly. It may be something that's actually super important for your particular job and your particular company. In most instances, either a software engineer or a machine learning engineer is probably going to be putting things into production, or at least that's what I have seen happen in other companies, and it's sort of my experience. And of course, your mileage may differ. It's a very young field. Sorry, my earrings are hitting the headphone wire, and it's really distracting to me. Okay. And the reason that you would want to build an API is to let people actually use the model, or maybe you have like some visualization functionality that you've built, and so someone can send you a data frame and you'll send them back maybe JavaScript code to generate a really pretty visualization, or anything where you want someone to interact with your code in a programmatic way without having to go and download your code and run it locally themselves. And I personally really like working in notebooks, whether that's Jupyter or our Markdown. And there are some places where their entire stack is completely in notebooks. So Netflix, and I linked a nice little article here where they talk about their architecture and infrastructure, if you're interested. So Netflix does pretty much everything in notebooks. They're very committed to the notebook ecosystem. In some places, that is not the case. And if you hand your software engineers a notebook and like, here's my model, put it into production, they'll be a little bit miffed. So I have a little quote here from Jeremy Kuhn, who's a software engineer at Google. And he says, I think the truth is any software engineer worth their salt will refuse to put a notebook into production. They'll rewrite it from scratch if need be. And you may or may not be working with software engineers who hold that opinion, but some of them clearly do. And if you are working with someone who doesn't want to put notebooks into production, handing them a notebook and then having them like rewrite it, maybe even in a different language, is maybe not the best use of their time. So what you can do instead of giving them a notebook is giving them an API. And we'll talk about what an API is if you're not familiar. So basically you'd give them a little application that you'd written that serves your model. And what we're going to be doing here is not going to be enough for you to put something into production commercially. So we're not talking about authentication. When we build our APIs, just anyone will be able to use them as much as they want, which is not usually ideal for commercial use cases. Usually want to like make sure that people are associated with an account. They can only get access to information their account has permissions to access. And also we're not going to be building any sort of database or storage backend. So we're just sort of building functionality where you send data, you immediately get information back, but nothing is stored. So that's another thing you'd probably want if you were going to put this into production. But we are going to get a good understanding of what goes into an API, the different parts, and then if you were to give sort of like a little baby API to your software engineering colleagues instead of a notebook, if they were of the anti-notebook for putting into production stance, then it would be a nice way of showing that you're a collegial person. And also, I use APIs all the time in my work, especially to get data. So I think the first API I ever used was the Twitter API, and I didn't know what APIs were or how they work. I just knew that I wanted tweets that had a specific linguistic quality, and it was really rough. The learning curve was very steep. I didn't really understand what was going on. I was getting these JSON files. I didn't know what JSON was. And now, having learned more about APIs and started to work on my own, I have a much deeper understanding, and it's much easier for me to use APIs because I'm like, okay, that's a resource, that's the method associated with that resource, and then I sort of understand the structure of the APIs. What's an API? So API stands for Application Programmatic Interface. So to use an API, you need two applications, one that serves the API, and then one that's talking to the API. An application is just code you're using for some specific purpose. It's super vague. And we're going to be writing a Flask application to serve our API, and then you can sort of reach out to it once it's hosted using any sort of internet-connected Python environment you have, or not even Python. Sorry, that's something I didn't mention. So we're going to be working in Python, but you can query an API from any language. It's sort of like a web page without like a physical thing you can click on. So we're going to be creating a Flask app, but then you can create a different application to interact with your app, and that application doesn't have to be in Python, which is another benefit of APIs because not everyone uses Python or not everyone uses R. Programmatic means that we're using programming. We're not going to be using a graphical interface with buttons like we see here on the Kaggle webpage. We're going to be using code to interact with our API. And then an interface means that the API is sort of the I guess like the peanut butter and jelly in a peanut butter and jelly sandwich. So the bread on each side would be the two applications, and then the interface connects them and allows bread particles to travel back and forth, I guess. That's a weird metaphor. I'm going to scrap that one. You can also think of it like a post office. It's the API that has a set of rules for sending things back and forth and sort of tells you where things are stored. So in the US, we have things called post office boxes, where you can rent at a post office and then you can send mail to and from that address. And for an API that's hosted on the web, that address might be a URL address. And we're going to be using REST. There are other ways of building API. I have encountered REST the most commonly. If you have a different favorite, congratulations, feel free to use that one instead. But we're going to be talking about REST today. And this is based on Royal Fielding's dissertation, which you can read here, which goes into excruciating detail. So a couple of key concepts. One is client server. So the client is what the person who's using the API is using to access the API. The server is where all the data is stored, where all the code is run. And so you send a request from the client to the server, and then the server sends a response back. So just like if you're browsing the web and you have, let's say, this page, which is on Kaggle, I haven't downloaded the entire Kaggle site and all of Kaggle's databases and everything on Kaggle to my local computer, and I'm not navigating around it locally. I'm sending a series of requests to Kaggle from my client, the Kaggle server, and then I'm getting information back. So if I don't really want to hit anything because I'm going to move around to the page. But if I went down to data, it would sort of bump me down, and that was because I sent a request and it changed the page. Actually, I don't know that that's true. I'm not a front-end designer or a web developer, so yeah, feel free to let me know if that is the case or not, if any of the Kaggle team is watching in the Slack channel. We also have resources. So we don't just sort of like send a bit string and then it's appended to the end of the whole bit string and there's just like one big long file that's all of the data. It's organized. And I think as data scientists, this is something that we would expect data to be organized. We have some sort of background with data structures and data organization. And each little chunk of data or entity is called a resource. So my resource could be a text file. Maybe I've got an API that will go and get the text of novels that are in the public domain. I don't actually know if Project Gutenberg has an API, but if it did, it might have objects associated. It might have resources for each novel in its library. It might also have a resource for each author. And we can also create links between resources. So I might say, oh, Victor Hugo wrote The Hunchback of Notre Dame or Notre Dame de Paris, and he also wrote Les Mis. And then I have a connection from one resource to multiple other resources. And then I don't want to get too deep into this, but the resource is like the file itself. The information about the resource is called a representation. It's sort of like an envelope that goes around the resource and includes the resource. And whenever I say resource, I mean a resource plus its representation, and that's where the representational in REST comes in. And if you care, there's a lot of resources out there. So we have a client and a server, we have resources, which are objects we can pass back and forth. We can get copies of a resource from our server. But how do we do this? What are the sort of verbs in this language if the nouns are the resources? And the answer are methods. So REST APIs are almost always served via web pages and HTTP. And there are a small set of methods, and these four are probably the most popular. There are a lot of other ones that people have added over the years for specific use cases, but these are the ones that we're going to talk about. So get is just sort of it's like a SQL query where you just return some data without changing the underlying database. So I can get information on resources without changing them. Since we're not going to have any resources actually stored, we don't have a database backend, we're not going to be using Git because we would have to have some place to store the resources and their representations to go and get them. Post creates new resources. So this is what we're actually going to be doing. We're going to be creating a new resource, and then because we're not storing it, it immediately disappears. But before it disappears, we get some information back as defined by the API. Put, which we can use to update existing resources. So if Victor Hugo came back to life and wrote another novel about being a playwright in New York City, we could we could use post to create another resource that was the new novel, and then we could use put to update Victor Hugo and say, oh, also he wrote this novel. I forget whether I said it was a novel or a play. I guess I'm on a Victor Hugo kick right now. And then delete, which is what we use to remove resources. So we have resources, which are objects. These are our nouns. We have methods, which are our verbs. And we're not actually going to be creating any resources, but I think it's important to understand, and especially when you are interacting with APIs that have big databases attached to them, which is most of them, that is how you will interact with them. A little redundant there. Okay, so I have built a little sample API for this that we're going to be working with through the series of workshops. And it does something kind of dumb, but useful. I see a lot of questions on how to get from a big chunk of text or a corpus of text a number of different, what's the word I'm looking for, to get in the instance and location of specific words. So maybe you have a list of company names that you're interested in, and you have a big list of patents, and you want to find out which patents have specific company names in them. And there's a lot of commercial products that will do this for you, but this will do the same thing. And I am specifically going to be getting the names of data science packages with an eye towards applying it to the Kaggle forum data, which we have shared publicly on Meta Kaggle dataset. So we could look at the popularity of different data science packages over time, as discussed on Kaggle, et cetera, et cetera. And my example that exists so far, I have the Python package names, and then with you guys, I'm going to be building additional functionality to get the names of R packages, R the language, not our, like the ones we own. But before I sit down and start writing any Python code, I am going to think about what I want my API to look like. What do I want it to actually do? And how do I want people to interact with it? At Kaggle Days last week, Francois Cholet gave a really, really good talk about user-centered design. So in developer tools specifically. So I can think about this as, okay, I'm imagining I'm a user of this because probably you're going to use it in the future. What do you want your process to be like? So what do I want my API to do? I want to send it some text and get back the location in that text of any Python packages if they exist. And we want to pass into it some sort of text. And we want to get back information on the keywords we found and where they are. And I am returning this information with the character index of the specific word that I'm looking for, because that's sort of the standard in a lot of NLP, and that will let me use this data output with a lot of different other things, other programs, other algorithms. So to answer those questions, we want our API to tell us where specific keywords appear in our text. And I'm going to pass in a JSON file. And the reason that I'm doing this instead of just a flat text file is because this is going to give me the ability to later on, if I want to add additional information, if I want to start creating resources, if I have a JSON file, I can add additional information in that JSON file, and I'm not going to have to change a lot of the sort of like plumbing to deal with a different file type. And then I'm going to get a JSON file back with our keyword matches and where they occur in the input text. And it's fairly, in my experience, the most common file type to pass to and from APIs is JSON. That may change in the future. I think it used to be XML. Again, I'm not a web developer, but this way it's a little bit more in keeping with the standards of APIs in general. And if I have a script that works on data from a different API, it should be able to work pretty seamlessly with data from this API because it's both going to get JSONs back. So once we break, if you want to spend a little bit of time working on this, think about what sort of API you would like to design. And of course, you are perfectly welcome to follow along with my code example and do exactly the same thing. But if you want to do something a little bit different, maybe you've got an image processing algorithm you want to use, or you have some sort of XGBoost model you want to apply to data, that is also something that you are absolutely welcome to do. And I want you to spend some time thinking about what you want your API to do, what you're going to pass in, and what you're going to get back. And then for if you're going to be doing multiple things, and I'll show you what I mean by that, you want to do that with each of the things that you're doing. Okay, so we don't have to just rely on asking ourselves questions about what we want an API to be like, however. Little sip of coffee. We can rely on the really, really rich ecosystem of existing tools for this. So there's actually a couple of ways to specify what's going to be in an API and what it looks like in the design. And I'm going to be using OpenAPI here. Oh, no, I added that in a new window, sorry. So OpenAPI used to be called Swagger. I've picked this particular one, A, because it's open source, and B, because it has a lot of really nice tools around it. So we can, for example, you can see that there's Swagger Code Gen that will allow you, if you have a specification, to create the code for that, for an application that meets that specification just automatically, which is really nice. And it's also very easy to generate documentation from your specification once you've written it. And if you're working on a company and they're using a different specification framework, use that one instead. Don't sort of like go reinventing the wheel and creating something that's not going to, gel well with the rest of your colleagues' work. So this is sort of the absolute minimum specification. And we'll go through the parts here. I go through them in more writing down here. So the first thing is that I want to specify the version of OpenAPI I use. I think the most recent one is 3.0.2. I've just picked 3.0.0 because it was the last major release. And I personally find it annoying to keep up with very minor releases unless it has something that's going to affect me particularly. And that's just my personal feelings as a developer. And then I have information about the application, the API that I'm developing. And each of these are required. So I have a title, a package name extractor. I have a description. This is an API that accepts a text string and returns package names in it. Sorry, this line overflowed a little bit because I'm really zoomed in. And then this is the real meat of the specification. So each specific activity or task you can do on the API with the API needs a specific URL. And that's how, when you serve the API, people are going to be able to use it. They'll be able to say, send this piece of information to this URL, and then you'll get your information back. Or if there is information back from that specific method, you'll get information back. This URL is going to be appended to the end of my URL for my API that I'm serving it. So if it's on Heroku, it'll be like heroku.myapp.whatever.URL maybe, I don't know, I don't remember, / extract packages. And if I had other things that I wanted to do within extract packages, I could have additional slashes here and create a hierarchical structure. So just like a file structure in a computer, you can have a hierarchical structure within your API. This is a very simple API that does one thing. So we do not have a hierarchical structure. This is a post method. So remember I talked about post, get, delete, and the fourth one previously. Post, get, delete, push, update, push, I think. So from that selection of methods, you should pick the one that most closely resembles what you're going to do. We are, like I mentioned, we're just creating a resource that is not going to stick around. It is passed into some Python code. That Python code is run. We get output back, and then the resource immediately disappears because we're not storing it. A description. So this is what this particular method does that extracts package names. The request body are the things that we need to send in. So the description is the what we want to be in the request. So you can see that I've said it's required, true. So we need to send some text in to get package names back. Otherwise, it's not going to work. And we are sending in a JSON file that I think I mentioned. And I say here that I expect the JSON file to be a single field containing text to extract entities from. So basically, I'm just putting quotes and curly braces around some string of text that I'm interested in to make it parse as a JSON file. And then responses. So this is a response code. So this is something that once we make our request, our server is going to send back to us. You may be familiar with 404, which means resource not found, I think. So if you get a response 404, it means the server's like, I looked, but it wasn't there. A 200 means everything's fine. Whatever you were asking for, it happened. And so if the server sends back a 200, which is a good job code, we're going to get back whatever the output is from the code inside our app, our Flask app that we're going to write tomorrow. And this returns the names and indexes of packages in the provided text. And I could even say character indexes here just to be a little clearer. So this is the very minimal example of a API specification. And I'm actually going to edit it, and I'm going to add a second method. So I believe I put a link in here, yeah, to the Swagger editor. So the Swagger editor is a free online editor. You do not need to, what's the word I'm looking for? You don't need to sign up for an account. You can just use it. And this is an example app when you open it, the Swagger Pet Store. And you can see that this is a much more complex, much more complex API than what we're building. So you can see that this one has responses 400, description, invalid ID supplied, 404, order not found. This is if you're trying to use the delete method, and it's specifically for orders associated with a store. So you can see this sort of hierarchical item. You can see this hierarchical structure here. And what I'm going to do is be super fancy and just copy and paste my API specification from my notebook into the editor. Choop, choop, choop. Oh my gosh, sorry. It's scrolling very slowly. It's probably because I'm streaming. Nope. Let me close all these other tabs so I don't get confused by them. So this is going to give me an error because I haven't finished describing my post method. So let me do that right now. Doop, doop. All right, I'll do just for me, I'm gonna add an extra white space in there. Okay, so this is our API specification for the very minimal package name extractor. So I mentioned that I already had the Python code written and I wanted to add our code. And what I want to do is create two methods, one of which will return Python packages and one of which will return R packages. So the first thing I'm going to do is I'm going to copy and paste this, and it will absolutely give me an error because I'm defining the same method twice. Yep. Duplicated mapping key. And I'm going to edit my first method, and I'm going to say extract packages. Oh, wait. Underscores are bad in Python. Python. And this I'm going to call extract packages R. And there is, oops. Sorry, you don't need to say paths twice. You only need to say that once. So now we have, you can see that this little interactive thingadoogle has updated. We have the Python version. It's got a request body required. On a 200, it returns the names and indexes of packages in the provided text. It returns application.json. It takes in a JSON file. And then we have the R package extractor as well. And I'm just gonna update this, Python package name, R package name. And I think that's enough updating. I think that that's pretty clear what each of these does. And they are more or less going to be the same from the API's standpoint, but the difference is going to be that the R package method is going to use different Python code than the extract packages Python. It's going to apply a different method to the data that we send in. So if we send in the same data to both post methods, we get different output back, is the idea. All right, that's pretty much all that I had to talk about. So what I'd like you guys to do, and I'm gonna go and answer questions now, but if you don't have questions, you feel free to use the rest of the time to work on this, is think about what API you wanna design, what do you want it to do, some more ideas. You could, if you've done sort of like the dog or cat detection thing, you could create something that takes in an image and returns whether or not the probability that it contains a dog and the probability that it contains a cat. I will warn you that the Heroku free API option will not accept images. Or it will accept images, but they have to be extremely small, which is why I picked a text project. So if you are doing an image project, maybe something that you would expect to have very small images from. Other examples, you might just have an API that you send in a number and it tells you if the number is odd or even, which is like, I don't know, kind of a silly thing for an API, but pretty quick to write the code from. Of course, you can serve a TensorFlow model, an XGBoost model, a PyTorch PyTorch model, whatever sort of machine learning model you would like, through an API as well. That's going to be a little bit more finagling, but I have faith in you. And those are the exercises for today. And tomorrow we are going to actually sit down, write the Python code, write our Flask app, and create our API. And then on Wednesday, we will serve it. Nope, on Thursday, we will serve it. And I'm ready to go for questions now. I see Jessica popped up. Do you want to take over, Jessica?
Thanks, Rachel, and thanks to everybody for tuning in. Now moving into live Q&A. We do have one question from a user. Her name is Rahul.
Seamless.
What are the pros and cons of building APIs by ourselves versus using products like SageMaker? And how would you compare these on things such as like cost for developing it, security, etc.? And this person is less concerned with the time taken to build the API in this comparison.
Yeah, that's a really good question. So it's going to depend. Actually, I guess I can look at you guys. Hi, guys. I've been here the whole time. Yeah, it's really going to depend on your specific team. There's a sort of like the general trade-off between open source, building it yourself, and using a commercial product that does it is developer time. So like my personal website is open source, and I've sunk quite a bit of time into that. But if you use a commercial product that builds websites, then it'll be faster, but it costs money. Some benefits of using a different service is that sometimes they will handle things like authentication and backend integrations for you. You have access to people who will answer your questions and help you out. That's not fair. You absolutely have that in the open source community, but it's not their job. So it can, there might be more lag, people have lives, you're sort of relying on the goodwill of the community. A benefit of doing things in open source is if something's broken, you can fix it, or you can ask to fix it and maybe they'll say yes, or maybe they'll say, actually, you broke it worse a little bit. It's really going to depend on your particular use case. Another thing to think about is software licenses and whether the license for the specific type of software that you're using allows for commercial use, because not all of them do.
Great.
It's a complex tapestry.
Yeah, it definitely is. Thank you so much, Rachel. We've reached the end of our session, but thank you all for participating in day one of the API workshop. It is a little early in the day, so if you have any further questions, Rachel will be sticking around in the CareerCon Slack channel afterward to answer them. So be sure to tune in again tomorrow and on Thursday at the same time as today for the rest of the API workshop. We'll see you all in a couple minutes for the next session.
Welcome to our second session of the first day of Kaggle CareerCon 2019. We'll be talking with Dr. Andrew Moore about his career. As a reminder, ask your questions in the YouTube live comments and in our CareerCon Slack channel in the designated session thread. We'll be asking some of them to our speaker here today. We'll note that we know our Slack channel is growing so rapidly that we're having to constantly refresh the invite link. So thanks for your patience. The link below is the most up-to-date link to join in the conversation. Now, it's an absolute treat for me to introduce my next guest. As of January of this year, he is the head of Google Cloud AI, having previously served as the head of computer science at Carnegie Mellon. Throughout his career, he's gone back and forth between academia and industry, and will be answering questions about the evolving data science industry, as well as his own career path. He's wonderful, intelligent, attractive, charming, and did I mention he's my boss? Everybody, please welcome Dr. Andrew Moore. Dr. Andrew Moore, thanks so much for your time today, and we're glad to have you.
Really excited to be here. This is a fantastic concept. I like these kinds of things, but it sounds like you've got a really enthusiastic audience.
Yeah, it is. It's been really a great morning that we had so far. We've had people coming from really all over the world who've been joining on the conversation. We're excited to have this conversation with you. I know I gave a very brief outline of your background. Would you mind telling us a bit more about your upbringing? How did you first get interested in just science and math in general?
Very good. Yeah, I grew up in a town called Bournemouth on the south coast of England. It's a pretty sleepy seaside resort. Very nice. I got to swim in the sea almost every day, which was cold in the winter, but quite doable. Cycled around it a lot. I first started programming in the 6502 machine code, wrote a few video games, really enjoyed that. But when I was like 15 or 16, I actually, it's that age, right? I became angry and crabby. And for me, it was, I was annoyed with the way the world was being run. It was the days of lots of upheaval, both in the UK and in the US, sort of the Margaret Thatcher, Ronald Reagan years. Historically, things actually turned out fine, but at the time I was really worried that the world was actually going to be devoured in a nuclear war. And so, while I was crabby about this, I can still remember thinking, I wish the world was run by benevolent, intelligent machines instead of these crappy humans. Now, in retrospect, please don't quote me. I do not still hold that view. But I was always intrigued about this question of when you can automate clearer, more rational decision making than using the sort of the wetware in our heads.
Right. That's interesting. That's hopefully. I mean, you are being watched by thousands of people, so that quote may get stuck somewhere.
That's okay. That's okay. One of the messages when you're 15 or 16, you're allowed to think that way.
Right. So with that and having that 15, 16, you're heading off to university. Obviously, machine learning and data science hasn't really established itself as a track. How did you choose the path? What sort of options were you taking in a formal education context?
So I started out in a program which was a 3-year math degree. Degrees of 3 years in Britain, and there was an option to switch to computer science after the first year. And I really enjoyed the math. I found it very hard to make the call, but my gut told me that there was more stuff I would be able to build afterwards if I had that computer science background. And I very much don't regret that decision.
Okay. And then you took that as in university and you continued on to a PhD. So how did you make that decision, and why not go directly into industry? And let me kind of tag on a follow-up also with that as well. Regarding your educational path, you mentioned you don't regret math, but overall altogether, was there anything you would have done differently? Or maybe if you were doing it today, would you have done anything differently?
The thing about the British education system is you really specialize. And I'm envious of my own kids now who are doing university degrees where they can do serious technology stuff, but they will also be talking about like the history of philosophy or the sort of world stage of world politics, political science, and these sorts of things. And I think that is actually extremely important. I think that right now the world needs people who are experts in domains going everywhere from space exploration through to child safety, uh, through to large scale investments in emerging technologies. And it needs those people to be very confident data scientists and automation engineers.
So that kind of actually jumps well into a next question. Is we've seen a number of people introducing themselves in our Slack channel, in the YouTube live comments. A lot of people are in college or they're about to start university, and that landscape has been changing over recent years. We're just starting to see universities offer degrees in data science or machine learning. What's the best advice that you would have for those who are trying to make the most of their college experience, and sort of how should they be approaching their studies?
So it's actually very related to the way that Kaggle operates. Learning by doing is really, really, really important. The one request I have, and this you're going to see me answering a lot of questions with, well, it's okay, you can do this or that, but there's something I'm frothing at the mouth passionate about. You have to take algorithms, you have to take probability and statistics, and I do think that you will be at a disadvantage in the long run if you're not comfortable talking about things like Bayes' rule, how you would use that to combine evidence from multiple different sources. If you don't understand why least squares as a fitting method actually makes an incredible amount of sense. And the reason is the tools and technologies will continue to change rapidly, but the math will not. And the laws of probability really are going to be there. And when I see folks who are not equipped with those two basic concepts, algorithms and statistics and probability, I see that those folks actually find it harder to keep up as the world just changes around them all the time.
Right. So actually, and I know we'll get into some of your career in academia, but if we can sit on this for a moment, you highlighted, the area that your kids are in right now and having a background in math, but there are many people who are interested in jumping over to data science. We actually have a whole panel tomorrow on career switchers, who have switched over. But how would you, maybe for those who they've already graduated with a degree, maybe a B in science and math, or maybe a B in more of a liberal arts, or a non-science and math perspective, what advice would you have to people in that area?
It will help you nevertheless to get to refresh probability. And I know that there's a huge variation in the way that statistics and probability are taught. And being very candid, I see plenty of cases where it seems like a statistics course is designed to make you hate statistics. Whereas in fact, the power of what you can do, if you know what you're doing with a notebook window and MLKit or something like that, is intoxicating. You don't have to do that awful sort of stuff that a traditional statistics education makes you do.
Right.
But later on, it still helps, at the very least, to be comfortable with playing little probability games, using Bayes' rule to sort of with a pen and paper, help figure out whether, given certain information, you would predict something happening or not happening. It doesn't have to be a deep university education in serious, like all the mathematical theory underneath it. But you cannot get away from the fact that in your career, you are going to be combining multiple sources of information, and you need to know the science behind how you combine those rationally. Even if you can't do it in practice all the time for other reasons, knowing what's really going on with data is important.
Right. So I'm going to put a quick pin in this because we're going to get back to it, but I want to sort of jump back to some part of the earlier part of your career. And I know we have a lot of questions coming in as well on some of the educational items and sort of the changes in the landscape and things like that. But your biography states that you were involved in a small startup earlier in your career. Can you tell us a little bit more about that venture, and then kind of tagged onto that, what advice would you have for people here about being interested in being entrepreneurial? Is the market too crowded? What is sort of your history as well as your advice looking forward?
Very good. My startup it was incredibly fun, and I think we did a lot of good, but it was commercially pretty useless. We we made enough money to support ourselves and pay our staff well, but we never really had a growth plan. So here's something I'm super proud of. In 1999, just for fun, in the window of our second floor of our startup, which is in Pittsburgh, there was a neon sign flashing data mining, data mining, data mining. And it turns out that in the entire history of the company, no one was walking along the street and saw that neon sign flashing data mining and said, "Oh, I need some of that. I'm going to walk in and get some of it." But what we did during that period was lots of work with industries which really had not heard of sort of doing algorithms and machine learning, and started working with them on applying it. And when we applied it, it was very successful. We charged on a sort of cost for work basis, which was like how much we were paying the consultants working with folks and adding 10% to it.
Right.
And so it was never really set to scale. And so we did it for many years. We did all kinds of interesting work in mostly in manufacturing. I had a wonderful, really fun week in a candy bar factory, doing some pretty sophisticated improvements to the production lines using data. Similarly with adhesive manufacturer, lots of work on production lines which were at the time just starting to get instrumented, and making sure that we close the loop with the instrumentation with machine learning. So really enjoyed it. I kept discovering that the limiting factor was not the accuracy of the machine learning model, it was the scalability. The fact is that back then in the early 2000s, 1 million data points was a lot. And no one could afford to just do algorithms which, put it all into memory and looped over it lots of times. And so I became obsessed, and I still love the question of how you optimally index data so that you can do these statistical updates very quickly.
So we were both at Google Cloud Next last week. For those of you who are unfamiliar, it's a big convention highlighting a lot of Google Cloud's technology with a lot of partners, and there are plenty of startups, plenty of building organizations that are building their brand from the ground up, or they're trying to get out there. Often in business, the joke is in the buzzword bingo chart, the free space is machine learning and data science. So for many people who are listening in and are wanting to start their own area, are there specific businesses that you feel like, in your experience, you've seen are too crowded, and on the flip side, are there some that you've perhaps seen you would like to see more startups using AI and ML in a particular field?
Fantastic question. Really, really, really good question. Okay, so overall, I'm not worried about crowdedness because the demand is so huge. 80% of companies are still not on the cloud and do not have access to their own data to do things. So there's lots and lots of useful places for AI within the commercial world, and then societally, so many parts of so many governments and nonprofits are probably 15 years behind a company like Google in terms of what their capabilities are. And so there's a lot of important work to be done to turn those things around. Having said that, in the startup space, I am much more nervous about startups which are providing a horizontal technology. And even now, so this will be, well, for everyone, we're going to provide a technology to make it faster to serve models. Or for everyone, we're going to provide a technology to add active learning to their conventional machine learning operation.
Trying to be more generalist rather than specialist.
Yes, exactly. So some of them will succeed, but the majority will discover that it's so hard to get the message out in a world where even the message of what machine learning is a hard message to have your voice heard above the fray. That's what I'm seeing happening to many of those companies. It's not a disaster. The people involved still end up in a really good situation, but the really good situation is, having been through that experience, they are huge targets for big companies like Google, Facebook, Amazon, and so forth, who really want to hire them based on those experiences. But it's rarely the case that you see those companies at the moment growing into something massive. On the other hand, a company which says, I am doing machine learning for radiotherapy, or I am doing active learning to help make sure that people who are evaluating security video are always making the right kinds of decisions. Those things, machine learning in an area or artificial intelligence within an area, I'm always very excited about. And those are the folks that are often going big.
Right. So Ashley, I want to go ahead and jump to a question that's coming in from our community that you touched on it, saying people who are in the startups, people who are starting their career in startups, have experience in startups, are often the ones that are being snatched up by the Facebooks and the Googles of the world. What are some of the skills that you would look for when hiring a data scientist? This is a question, by the way, that comes from Purva. I believe it's Hilgal. I apologize if I'm mispronouncing that name. Purva Hilgal. What are skills you look for while hiring a data scientist if he or she is just starting out in the field?
Great. So, I'm not going to walk through the whole Google methodology, because that is available online, and I can't remember it off the top of my head.
We have a session actually with the lead staffer from Google for data scientists. Okay. That's coming later.
So this is me, Andrew Moore, person in the street, giving you a feeling for what I'm looking for in these situations. The most important thing is that it's someone who's shown evidence that they are interested enough to have built stuff. So if someone has, by the way, there's nothing wrong with this. If someone is in a stage of their career or personal journey where they've had a lot of chances to read about machine learning, or perhaps help with sort of framing of machine learning policy and these kinds of things, that's perfectly valid, but it's a less useful skill right now than someone who, when they see a bunch of data and they realize there's a pattern, there probably is a pattern in it,
right,
that's useful, they cannot resist just getting out their favorite tools. And I don't care if that's a spreadsheet or a regular Python script or a typical notebook, or a fancy thing like one of the cloud platforms, or just jumping in and using TensorFlow or Spark directly. I don't really mind what form it is, but I like to see folks who have shown that curiosity and fearlessness of just going in and messing with the data right from the start, and who, when we're talking about data science, it keeps coming back to some real issues that they've encountered while they've been messing with data.
So it's interesting. Actually, we had another question that just came in, and we'll jump back to some of your other career part as well. But I think this is a fitting part. Shanya Sharma asked, there are a lot of product ideas that I have, but it feels like I don't yet have the skill set to complete those projects. What's the best way of going about these projects? Sort of as an option A, which is, do I start implementing the project and learn as I go based on the requirements? Or option B, do I get a deep understanding of various algorithms and develop the skill set that I'll need and then start the project? I'll have you repeat that from the beginning if you wouldn't mind.
Sure, yeah. I'm firmly in favor of the first. You do not need to feel like you're a super credentialed expert to try stuff out. Try things out with the data using your own creativity and your own knowledge that you've attained so far. Like follow a typical recipe in a Coursera tutorial about applying some neural network package to a set of data. That's fine. But what I ask after that is, and this requires another set of skills which probably have never been taught. You've got to seek out an experienced, friendly person who you can run your thinking by. And that could be, you know, a student a year ahead of you. It could be a buddy from high school who's working on similar kinds of things right now. But as we talked about already, if you want to become an expert in data science, you've got to have attempted to do it and learned while you're attempting to do it.
Right.
There are some really serious mistakes that it's possible to make while doing these things, but you will learn them much faster if you just make them and seek help. A note for experts in the room, I think the data science community is really good at this, but you never show disrespect or, God forbid, contempt for someone who is taking this journey and is making some newbie mistakes, because that is the most efficient way for them to learn.
And we all started somewhere.
Yeah, exactly. So it is a phenomenon that some people really do find it hard to start working on something when they don't feel deep expertise. And I do appreciate that. And if you want to go and get the deep expertise first, that's okay. But if you're in a position where you're choosing one route or the other, I'd say begin with the applications. And then when finally you start getting trained, you'll say, oh, yeah, I see why this section of this chapter is really important, because I made that mistake in the past. I used cross-validation so intensively that I'd overfit the cross-validation level of my model or something like that.
That's really great. And we had a little tangent there. We'll come back to that in just a moment, but I want to jump back to another part of your career. So I know you had your time in academia and in the startup, and then you were at Google, and we'll come back to that time at Google in a moment. But then you went back to academia. So you were obviously at Carnegie Mellon. What inspired your decision to go from industry back to academia?
So the thing that I've actually been pretty consistent about in my career ever since I was that angry 16-year-old is that in the overall space of things which the human race can do to continue its hopeful gradual improvement, both in terms of comfort, safety, justice, and quality of life. Artificial intelligence, I have always believed, is one of those things which is as exciting to me as meeting alien civilizations or time travel or longevity research. It's one of those science fiction-y things, but it stands out as different from them because it's doable. And that has always gone with me. And the using it in my first round at Google was very, very exciting, because there I was lucky enough to be part of the advertising targeting solution, which is the part of Google which makes sure that if a user query, it's pretty clear that the user does not even want to see ads, we show no ads. And if the user query could actually benefit from ads, we make sure we show ads which are actually useful, and not, for instance, the ad which would be the highest click-through rate, the highest monetary value.
Right.
So that was fascinating. And to work on that problem, we built a machine learning system at a scale that I'm fully confident no one in the world had done before. And just to be clear, this wasn't my work. This was me being a part of something very big, which is going on around all of Google. I helped in the various corners of that. But the level of ingenuity made me really feel like this was part of the story of how artificial intelligence becomes useful for the world. After 8 years of doing that, I'd begun to get worried about a second thing, which is that there aren't enough folks trained up with these skill sets. And that's why I made the decision to go back to in this case, it was Carnegie Mellon University, to work on all the aspects I could find of making sure that we had more people going into these areas, more diverse sets of people going into these areas, gender diversity, underrepresented minority diversity, economic diversity, and start working on some of those thorny problems. At the same time, I am very aware that, at least for me, academic research as opposed to commercial research is sacred. Academic research is where the big companies like Facebook and Google have, in the end, got their ultimate game-changing concepts for. And we have to support academic researchers and people who want to do PhDs. So I wanted to help secure that.
So what advice would you give to people who are interested in going into academic research as a part of their career path?
I think it's a extremely positive and pleasant thing. Do not do it just for the credentials. Right now, if you want to be right in the middle of designing new products and services in the AI world, you absolutely do not need to get a PhD to be taken seriously. You do not need a master's to be taken seriously. 3 or 4 years after you've got your highest piece of education, you will be recognized for what you've accomplished. Not people won't really care about what's on your transcript or your degree. I'm speaking broadly here. Saying people won't care is not fair, because there actually are plenty of employers who, in their initial stage of resume screening, might actually take that into account. Though I think those employers are becoming unfashionable, and that will be less common. So do not do a PhD because you think you have to get those kind of career points in order to be successful in the future. Do a PhD if you want the absolute master's class in how to try to solve big technology and science problems that no one else has been able to solve before. Yeah. It does give you one of many life experiences where you are kind of scarily actually competing with everyone else in the human race who's tried to work on these things. Right. And for folks who come through that, they do think differently and a little fearlessly, but it's one of many paths you could take.
Yeah. So there's 2 questions I have to follow up, and the first one, you somewhat alluded to this, but you know, as I mentioned earlier, a lot of universities are just now developing curriculum or degrees for data science. What is your opinion on more self-directed learning and non-traditional learning, like MOOCs or data science boot camps? You know, Kaggle has Kaggle Learn, Coursera, Khan Academy, all these. What is your opinion on those versus a more traditional brick and mortar institution?
I think self-learning can be very successful, and I've been amazed at many of the self-taught data scientists that I've met, and I have great respect for them. I feel, and this is based on research that I cannot reference right now, but I can bring it up. In terms of whether to use MOOCs, I think that's great if it works for you. It's about the same learning value as using textbooks. But for some people it could be more entertaining, some people could be less entertaining. So don't feel like you have to do an online course for it to count. You actually, the same learning outcomes, whether you've self-taught textbook-based or video lecture-based. And then in the very early stages, you will probably want to do the exercises, some of the exercises from your book or from your online course. At the point where you've been through and you feel you've learned some skills, that's the point where you really do want to go to a place like Kaggle, or just look around government databases and ask yourself the question, is there something that I would find it useful to try to predict or model as to what's going on? And that's when you try things out, you make mistakes, and you need, and this is where a traditional brick and mortar university can help a little bit, you need to have mentors around you or friends around you who you can share your mistakes with so that you learn. So this kind of spins into a question that's been coming up pretty frequently in our discussion channels, and this is from Rajalakshmi Ramesh, and actually
the lead off saying there's a condition prevailing in India. I would say it's not just India, I'd say it's all over the world. And you alluded to this a little bit earlier by saying that the institutions that are looking for professionalized degrees, or the companies looking for that will probably outcompete it at some point. But what Raja Lakshmi asks is, there's sort of this chicken and egg problem when it comes to choosing data science as a career. What the company or hiring managers expect is experience, but as new data scientists, how can you gain experience without the job? This happens across all careers, but especially in data science where there isn't that academic foundation. So how long can one person work on a Kaggle competition data set? At Kaggle, we have the Titanic as a big introductory data set, or any other data set at home, and then claim, hey, I'm a data scientist, I'm an analyst, I'm ready to do this. And why do you think it is that companies are not yet ready to view projects as proof of skills? They expect only job experience, which you can't get without being entry level, and you can't get entry level without the job experience. So how can you move forward with a career when you're sort of in this chicken and egg type of situation?
Yep, it's absolutely true, and it really does help for job hunting to have some kind of experience. And I do fear sometimes that's an advantage of traditional university education, is you get the letter of reference and recommendation from some of your professors, and that gives you that extra step up. And in some countries, including the United States, I think that's annoying because you have to pay such a ridiculously large amount of money in order to get that extra thing. So I wish I had an easy answer, and I don't. The one of the things to remember is that the companies hiring are concerned not only about data science experience. That's what stands out, but they need some other proof points that it's someone who's good at communications, can work in a team, and has a history of sort of successfully delivering rather than starting things up and then suddenly stopping them and so forth. So those are all skills which folks hiring do care about. And the problem is that just having, I say just, it's obviously a huge accomplishment, but having sort of successfully done projects within Kaggle is a necessary condition, but it's not sufficient when folks are going to want to at least check in interviews that you have these other three abilities: communications, getting.
We have a little bit of a connection error there. Oh, there we go. Sorry, I think it was just a brief list there. So thanks. I think we're back here.
Okay.
I think that's great, and something actually that you alluded to a little bit, and we have a session on during CareerCon is how to create your own personal brand, even if self-promotion isn't your thing. So this idea of and as well as how do you land your first interview if you don't have personal connections. So it is mentioned that these can be very important, but in the data science world, where it is a lot of self-starters, a lot of people like you mentioned who the skill of not giving up on a project is out there. Don't worry, for those of you watching, we have a couple sessions on that as well. But I know it's a little bit of still up in the air, and I think we are seeing the industry start to shift more, as you mentioned, towards the value of projects rather than the value of what a specific line on a resume is.
Yes.
So you then came back to Google once more. Obviously, you've been here for a few years. What are you most excited about in your current role?
So this is it. For me, this is the point in the history of the world where artificial intelligence starts getting deployed usefully around the world. And I want to see it through to make sure that as we deploy it, it actually is making life better for folks in the world, that it is increasing the pace of scientific advancement, that it is not restricted to rich industries like internet and banking who can afford it, but it actually does go out there to help things like public health and Veterans Administration and NASA and USAID or UNICEF or many of these kinds of places out there. So it's now there actually are some amazing new things coming down the pike in artificial intelligence. I'm happy to talk about those. So that the basic set of tools you'll be using and building from will change radically over the next 3 or 4 years. But having said that, the place where I am taking cloud AI is down the path of making it realistic and efficient to do these artificial intelligence deployments so that they all get out there as quickly as possible.
Right.
And the sort of, it sounds so obvious, but it did take me decades to learn this. So it is not just about seeing where technology can solve a problem. If someone comes in and says, listen, my organization is like, my health organization still has hundreds of potentially preventable deaths because of this issue. When you start working on it, it's not enough to say, well, you should be using this kind of regularizer in your model instead of this one. I really wish that it was sometimes that simple, but in fact, a lot of it is talking about the way that the organization, which is adopting AI, is currently organized, helping the organization be ready to change its operations so that it can be using decisions coming from automated systems as part of an overall process where there are still humans in the loop at the right place, and all the stakeholders are happy that we're putting in the AI, not threatened by it. So more than 50% of an successful AI deployment project is non-technical. And that's one of the places where I'm super investing for Google AI. I think we might be the first large organization to really systematize the fact that it's a combination of societal, psychological, and technological things to get AI out there.
So you kind of already addressed the question I thought was going to try to trick you, but I want to pull the thread just a little bit further. What would you say to aspiring data scientists who feel like they have to compete with these automated tools like AutoML, H2O's driverless AI, DataRobot, where we have these tools that are now competing at a pretty competitive level with someone creating their own model? Would you direct them more towards that other 50%, like you mentioned, of the implementation? What would be sort of, obviously you're speaking both on behalf of AutoML's employer or creator, as well as people who are trying to get their own job, but how would you sort of provide some encouragement to those who may feel a little bit defeated when they see some of these automated tools doing so well?
Yep. Well, it is very, very much the history of technology that things do get automated. But often what I like about being a computer scientist is the things that get automated are often the slightly boring and frustrating things. So no one really enjoys writing a script to sort of iterate over a bunch of potential features to hold in or to remove and do each of these things. That is less interesting and so should be automated. Now, there are other things which no automated method, at least not for at least another 10 years, will be able to do. This is, and actually comes down to some of the fundamentals, combining information from several different data sources. So let me give you a good example here. Suppose you're trying to figure out what is causing people to fall out of a cigarette cessation program. Like for some reason you're part of the government or a health product company that's working on cigarette cessation, not sensation. Maybe it turns out you've got for 3 different regions in really in-depth studies where people with clipboards have been creating huge amounts of very personal data through paid studies, talking about every aspect of a smoker's life or an intended ceaser's life. But at the same time, you've also got a whole bunch of massive scale data from the internet around people in different regions, what what they're doing on the internet in terms of searching for cessation programs, plus several other forms of data. And they don't all match up. They're not in the same event space. So you can't say, all right, my training set is going to be all the people that we've tracked who've tried to cease smoking, because then you're throwing away a whole bunch of data, which is sort of aggregate statistics from, say, local government studies or so forth. And when you start to try to combine these things, it turns out you don't usually want to do something like a straight machine learning model. You actually got to jump out of the old recipe of saying, all right, first job is to process the data so that I got a bunch of predictive variables and one output variable I'm trying to predict. That is, at least in my experience, the minority of cases where these things get deployed in real systems. Instead, you've got multiple forms of data. And here I'm going to speak a little mathematically, which is not, don't feel like you have to be able to use these terms, but there are some latent variables going on in the system. And all the different data sources are evidence to support what the values are of those latent variables. And with a little bit of math, you can work out then things like traditional classification or regression types of models, where you are trying to find the values of those latent models which best match all of your data, and work that way. So those kinds of things, that is much more of a human software engineering, data design type of skill, to be able to really start to think of what's going on really in the real world and how do I try to model that with multiple sources of data. And once you're doing that, then you quickly then find out, oh my God, I got 7 different subcomponent models I need to learn and optimize, and I only have 4 days left to do this. I'm really glad that there are autonomous optimization algorithms to go and help me deal with each of those directly. But my problem now, my intellectual problem, is how to combine that information to come up with the best overall prediction.
So you heard it here first. You have 10 more years left. 10 years left, and you have until 2029. No, I think it's a great answer. I think I really appreciate you saying that. So just a few more minutes left, and if you wouldn't mind, a couple questions as we conclude, as well as a few more that we'll reach out to the community. First off, it's just sort of the overarching part of your career, right? You have the angry teenager to university, academia, startup, Google, academia, Google. That whole lifespan, that arc. Looking back, is there anything you would have done differently? And then similarly, if you were to try to start that same career today, would you do anything differently today looking forward?
Great question. Overall, I'm pretty happy. I think I was probably lucky. The ability to decide to change direction occasionally is something that's worked for me. I'm not saying that everyone has to do this, but if someone does decide to work on the same career ladder for 30 or 40 years, that's fine, as long as there's really is the person is really taking time to ask the question,
right?
Time for me to refresh myself and do something else. I found some parts of the changing career really, really difficult. And in fact, one of them, when I first moved to Google and had to suddenly transition from being a confident academic who knew how to run big research projects into a person responsible for shipping software which made the New York Times if it went down.
Right.
I was completely unprepared for that. And so during that change, I suffered. I spent at least 6 months being incredibly anxious enough that I was sort of dysfunctional. And in retrospect, I've often asked myself, how could I have given myself a smoother ramp there? But part of that was something which I learned a lot during that experience. And now it means that I'm lucky that I can think like an academic and how successful academic projects work, and think about how to make realistic large-scale software deployments work. So I do think it's worth changing. I do think that changes, at least for me, have always been really tough, and one of them nearly broke me. But it's I'm now glad that I've got a bunch of different sort of backgrounds which help me make decisions.
So I have three final questions for you, and the first one is interesting that you mentioned that sort of switching back and forth, and then your metric of success kind of changing. This one comes from someone in the community, Aisha Mahajan. What was the first time you felt successful? And can you describe that feeling? Is this feeling something that motivated you further?
I I think this is going to be true for many of us, but I don't think a lot of folks, myself included, actually ever stop and say, "Oh, I'm successful." Uh, and I'm not trying to do false modesty here, but yeah, I'm not usually very satisfied with what I'm currently doing, uh, and it's so yeah. I think I would say I've never really felt successful. I've always felt I like everyone suffer from imposter syndrome. Uh, right now in my current job role, I'm excited and have butterflies in my stomach about some of the big new things we're going to try to do, but I'm not going to label it as successful until I've seen it actually work. Uh, Again, we're all different personality types, so I do not want you to think that what I've experienced in my career maps onto what you've experienced. I have got less happy as I've begun to think that in my career, as I've begun to think that things are running smoothly.
Right.
For me personally, I think I need some anxiety to get me excited about getting out of bed in the morning.
Sure. No, that's good. Actually, we're running close to the end of time, so I'm just going to close it with one final question. It's a little bit of a trick question. What is a question that I should have asked you, but I didn't?
What's the difference between artificial intelligence and machine learning?
Would you like to answer it for us?
Oh no, what a surprise. All right. I really care about this because, and I do think this is very, very important for folks who are into data science right now to understand. Artificial intelligence is about this full loop of human-like cognition of saying, I sense the world, I make a decision, I act in the world, I observe what that does, and I keep going around this loop. It's all about closing the loop on these predictive systems. AI was exciting, but kind of mystical until we got serious about machine learning. The reason for that is in that AI loop of perceive, decide, act, the decide part needs models to predict the effects of actions. And we didn't really have that until machine learning became real. What I don't want anyone to do is to forget the full loop and where I get excited and where suddenly I'm directing my existing projects and have always done this is making sure that the machine learning things that we're doing are in service of closing the full AI loop.
Right.
Machine learning is a very important component of the dream of artificial intelligence, which is the perceive, decide, act loop, acting at a apparently human level of intelligence.
Right. That's fantastic. Dr. Moore, Andrew, we really appreciate your time today. Really helping us kick off this CareerCon, being one of our first panelists to have this type of discussion for. I know the thousands and thousands of people who are watching have found great use of that. So I'll let you go. Let you get back to your work. But once again, thank you so much for the time that you have here. For those of you who are also listening in, we're going to get started on our next session in just about 10 minutes at the top of the hour with a panel of working data scientists. We ask them some questions as well. But finally, once more, Dr. Moore, thank you so much for your time.
Everyone who's watching, you're in such an exciting field, at such an exciting stage of your career. You just get my full best wishes. Thanks.
Thanks, everybody. We'll see you guys back again in just about 10 minutes.
Welcome back to our next session. Again, I am Jessica, and we are commencing with a panel conversation with working data scientists. Perhaps both a good and bad thing, there is no single prescribed academic path today for going into data science. Many backgrounds can actually feed into the field very well, but the path to get there can be unclear and daunting. That is why I'm here with 4 data scientists today who come from very different learning backgrounds, ready to share their stories and best advice. We have, first of all, Rosebud Anwuri, a data scientist from Ernst & Young. Rosebud's background is in chemical engineering, and she learned all of her data science knowledge from various online courses, also known as MOOCs or MOOCs. Next is Alyssa Columbus, a data scientist at Pacific Life. Alyssa comes from a mathematics background and has learned much of her predictive modeling and machine learning skills throughout various academic and job opportunities. We also have John Alexander Holt, who is a data scientist at CKM Analytics. John has a BA in German studies and has participated in a boot camp to help him get to where he is today. Last but not least, we have Alison Hegel, a data scientist at HackerRank. Alison received her PhD in English and has expertise in textual data analysis using machine learning and natural language processing. So that's just a very short intro for each speaker, but obviously this is a panel conversation. Really excited to get to know each of you better. So all right, let's get started off with the panel. Why don't we start off with learning more about what each of you do at your jobs? What do you do in your role day to day? What kind of problems do you solve? Rosebud, would you like to go first?
Sure. So basically at EY, it's pretty much the standard analytics type projects, but really what really makes it special is the fact that it's done on a really large scale. So we do it for really big companies, for the government, for society at large. We pretty much solve pretty complex problems across different industries like retail, manufacturing. Usually day to day involves talking to clients, understanding what their business objectives are, because at the end of the day, data science is really an enabler to the business. So really understanding what they want to do, going back, building dashboards, building predictive models, querying data, doing data analysis of all that sorts, and going back to the client and presenting our results. So it's sort of an iterative process. So the client says, oh, we want it this way, and we don't want it this way. And we just keep on going on that. Usually most of our time is spent making sure the data is correct, because like 80% of the time you're just trying to validate and make sure data is correct, make sure data is complete, because usually if that foundation is not right, your whole analysis just sort of topples down. So usually that's what my day-to-day looks like. Yeah.
Great. Alyssa?
Sure. So at Pacific Life, we use all sorts of different tools for data analysis and visualization, R Python, Alteryx, Tableau, etc. And in my job, I'm an interesting cross section between product design and product marketing, where my analytics drives the marketing of our products and also the design of our products. And sometimes we get feedback from the different marketing and design teams about, oh, this product would be an ideal design, but oh, we can't market it that well. Or we can market this product very well, but it won't be very great for our bottom line. And so my analytics helps to drive all of those different thought processes. And I use the tools of R and Python mainly. I build a lot of R Shiny or interactive web applications or dashboards. If you haven't tried out R Shiny yet, I highly recommend you should. A lot of companies use it in production now, and it's just incredible what you can do with Shiny. Also, I write a lot of R Markdown documents to automate the reporting of sales and different metrics at different levels, and also by varying demographics. I also write PDF scrapers. You wouldn't believe how many applications there are for PDF scrapers there are at an insurance company or really any company. And then along with building all of those really cool things, I build predictive models, mainly GLMs for their interpretability, though I also build machine learning models with TensorFlow as well.
Great. John?
Sure. So at CKM, we dabble in a lot of different things, actually. So we have projects going on that involve NLP. What I primarily have been working with for these last couple of months has been log and network analyses. So a lot of process mining for businesses and trying to understand how their operations are running, how we can enhance them, what they can do to better those processes mostly. We have machine learning projects. So what I have been doing mostly has been a lot of network analysis. But I've recently switched teams. So we're doing some sort of DevOpsy sort of work where we have switched over from Python. We're doing a lot of analysis in Kotlin, Kotlin and SQL, and building a dashboard with Spring Boot to sort of synthesize a lot of the analysis we've done for companies over the years, and trying to put that into one tool that you can use and manipulate as you see fit for whatever sort of needs that you have. So getting a new set of skills to go along with the statistical analysis in Python, and yeah, sort of diversifying even more.
Mm-hmm. Wonderful. And Allison?
Yeah, so I'm a data scientist at HackerRank, and this is my first job out of grad school, and it's been amazing because I've gotten to do so many different kinds of things. So if you've never heard of HackerRank, we're a company that helps companies hire developers. So we offer screening tests and some other tools to help developers, show off their skills. And there's a lot of things that you need to do to make sure that that process goes well. So one of my main focuses has been on test health. So I try to make sure that we have some really solid metrics for determining whether our tests are doing what they're supposed to be doing. They're not testing the wrong kinds of skills. They're not too easy or too hard, and things like that. So I've been doing things like defining metrics, building data pipelines to get all the data aggregated properly, and then building a dashboard. And now it's actually a page in our product to basically get that test health information to our customers so they can improve their tests and make sure candidates have a really good time on our platform, as good a time as a coding test can really be. And another thing that I've been working on is taking the feedback that we get from those tests. After candidates take a test, they give us some feedback, and I built an internal web app using Django that helps us sort of sort through those comments and get the right comments to the right people. Like if it's about our design, we get it to our design team. So all kinds of different things related to helping our product do even better.
Yeah. Oh, that's so fabulous. I feel like through a sense of all four of your jobs, we really come to this common sort of notion that data science is a very flexible field, but yet very applicable across multiple different kinds of fields, and it requires a lot of flexibility and a lot of on-the-job learning. So it's really great that all four of you have really been able to do that at your jobs. So great. Now that I got a better sense of what each of you do. Let's talk about how you got here. So could you walk us through your education background? Let us know the formal parts as well as any more impactful and self-directed or non-traditional parts. Why don't we go reverse order? Allison, you want to start first this time?
Me again, yeah. So as I said, I finished grad school. I actually did my PhD in English. So I'm a very non-traditional learner, and I had to do a lot of supplementing my English education with things like online courses and just going up to the linguistics professor who was doing a cool project and saying, hey, can I talk to you? Can I learn about what you're doing? So I definitely think that my English background helped me a lot, just in terms of communicating. If somebody asked me to give a presentation, I'm not scared of that because that's pretty much what I did in my PhD constantly. So things like that, and just sort of sitting in meetings and not being afraid to, disagree with people if I think they're missing something, or just really being confident communicating verbally and in written communication. So I think both the humanities background and sort of supplementing it and being not afraid to sort of take a course on something you've never even heard of before online, and not afraid to come up to talk to somebody who has some kind of expertise in something you are terrified of learning about, but finding out that they're so generous and willing to share their knowledge. That's been kind of what my background looked like.
Awesome. Cool. John?
Sure. I had a sort of a strange path to get here. So when I was in school, I studied German studies. I studied in Berlin for a year at the Free University, and it was great. And upon leaving school, I was ready to join a program that would involve me doing a law program in New York and then a law program in Frankfurt for a 2-year sort of deal. But it turns out I forgot to fulfill a requirement for my schooling. So I had to take a summer class. I had to take a science summer class. And while I was there, I was thinking, wow, I really don't want to take one class. And so I ended up also taking a programming course that I ended up really liking. So I figured I would continue with that. So I found sort of a new passion upon leaving school that I didn't think that I would have. And so I took that course, and then I actually went to Rutgers because I'm a New Jersey native. I went to Rutgers for a web development coding bootcamp, actually. So that was a 6-month program. I sort of learned the basics of anything one would need to know. So HTML, CSS, JavaScript, sort of that basic stack. And my first job in that sector was actually a PHP position file. And as I was looking for avenues to continue using it, one of the things that continually popped up was data science. And so I remember really liking stats in high school. And so then I found out more opportunities where I could learn to actually apply my Python skills. So that's when I signed on with Thinkful for another 6-month learning opportunity. I just love learning opportunities. So that's when I signed on with Thinkful. And that really gave me the refresher on all of the math that I really hadn't kept up with for a couple of years, and allowed me to use the sort of the relevant libraries in Python that I could continue to use. And so after I finished with Thinkful, after I finished off with the mock interviews for that program, and I felt ready to interview. So that was about last summer. And so that's sort of how I came to be where I am now.
Great, great. Cool. Alyssa?
Well, I knew that I always loved math and I always had an interest in science. So what people usually recommend to people like me is to go into engineering. So at first I started my education in college with an engineering degree. And as I took more engineering classes, I realized I didn't enjoy building things as much as I enjoyed the underlying math and statistics underneath all the engineering. And so that's when I decided to switch my studies over to math and statistics. Also at that kind of same time, I landed my first analytics internship. And I really enjoyed what I was doing there. I really enjoyed going through data and discovering insights or discovering truths that are not immediately apparent from looking at numbers, but having to work through them first and dig into them. And so, yeah, that basically sparked my love for analytics and data science. And so I studied harder in college, got applied in computational math specialization for my mathematics degree, took a lot of statistics courses for that specialization. And along with all that math background, I'm mainly a self-taught programmer. I did a lot of online free courses in programming to supplement my math education on Coursera, edX, DataQuest, Udacity. I think I even took one Kaggle course. And I also earned some certifications from Google, HubSpot, Salesforce, related to analytics because I was just intrinsically interested in analytics and also its intersection with marketing. And yeah, all of those educational experiences combined gave me a very holistic view about how analytics and data science really functions in an organization and how it can really benefit an organization through the communication and collaboration of different teams.
Yeah, totally. And Rosebud?
Yeah, so I think I and Alyssa have a lot in common. I was also pushed into like an engineering background because, I like math and science, do engineering. And I found myself doing chemical engineering in school. I would say that my data science journey really started around 2014. I had just returned from an internship with an oil and gas company, sort of like something that's more in line with what I did in school. And I was not satisfied at all. I was like, I can't do this for the rest of my life, basically. But I had no idea what I was going to do. So sort of like unconsciously, I was sort of seeking out like a new field that I could probably work in. And then I came across this book called Power of Habits. The book has nothing to do with data science, but there was a particular story about this infamous retail store that sent a catalog of baby stuff to a 14-year-old girl, and her dad was really angry, wanted to sue the company, and they later found out that the girl was actually pregnant. And I was like, what is this magic? I need to find out what this is. And I kept on, I had no idea what it was, because at the time, I think in the book, they used some vague term, like maybe statisticians or something. And I stumbled on Quora. So my learning part is extremely funny. I stumbled on Quora and I saw an answer about what do you want to do if you want to get into statistics, data science, and stuff like, oh, there's a word called data science, cool. And then the very first prerequisite was programming. I hated programming in school so much. Like, in fact, as a, I think I deliberately did not read for my exams because I was like, I'm not doing this. I'm never going to touch programming in my entire life. But I literally just saw that as the first prerequisite. And for some reason, I wasn't deterred. Like, usually I'll just close it. Okay, moving on, looking for something else. But somehow I did my first programming course. It was extremely hard because I was literally just in a dark room alone, doing stuff on Codecademy, trying to find out what for loops and while loops mean. And it was pretty intense at first. And then I did my first programming course, my first analytics course rather, the Analytics Edge. I loved that course so much. It was extremely challenging, very interesting course. And I really appreciate that I did that course at first because it gave me like a really good high level review of what is possible with data science. So when things are really hard, when I don't understand the concepts, when the maths is really hard, I think if I understand this maths, I can actually do X, Y, Z. I can really do like really big stuff. And so I did that course. I did like 15 other courses on Coursera and EDX, like within 1 year. I was just doing courses and doing courses and doing courses, looking for more knowledge. I was really interested in looking for more stuff. At some point, I sort of plateaued on the course side because usually the courses sort of focus on beginners. So it sort of gets a bit repetitive for me. So I started my blog. I started doing a blog on like using data to answer very random questions like can you predict who would be like the top club for the English Premier League, or can you talk about like why billionaires are actually billionaires, some very random stuff. And I would say that even if my courses gave me like maybe 30% of my knowledge today, doing those personal projects, pushing my skills myself, like gave me the rest of the 70% that I know today. So like my skills really took off when I was basically doing stuff on my own, checking Stack Overflow. So basically all my knowledge is from MOOCs and Stack Overflow.
Yeah, oh yeah, totally. I love that there's a theme here. And being a data scientist myself, I also came from a sort of non-traditional background in geography. So I really agree that it's a journey. Being in data science is such a broad term. You don't just find it overnight and you just suddenly are a data scientist the next day. And I think what I really learned from all of you and affirmed is that it's okay to take time to figure it out. Perhaps one of the best things about the field is that it is so accessible for learning. We have MOOCs, right? We have boot camps. You all mentioned those. Stack Overflow, even just online resources. There's plenty abound to help you sort of piece together that learning bit by bit. And don't be afraid to do that, right? So that's really great. I have a couple of community questions now. Tuning in live. So let's start off with Purva Huigel's question. While looking for opportunities, there are positions like data engineer, machine learning engineer, data scientist, big data developer, etc. Is there a basic difference between these positions? And why don't we start with Rosebud this time?
Yeah, okay. So it can get very confusing, to be honest, for people that are very new to the field, and sometimes even so for some companies, the roles overlap a lot. So, but in theory, statistics and the maths programming knowledge, machine learning engineers are more probably software development backgrounds that moved into data science and they build production ready models and stuff like that. Data engineering really focuses on trying to build a good pipeline for getting your data. So they extract, transform and load pipeline for the data scientists to work on. Basically, so building a very good data warehouse, data ecosystem. Big data developer, that's a very broad term. It could mean anything, but again, at the same time, I think it's a bit close to a data engineer, and at the same time, a bit close to a data scientist. So they sort of overlap sometimes. So yeah, it can get very confusing. So my advice would be to really look at the job description, also look at what the responsibilities are going to be and what they expect of you in terms of like your experience. So you could see that if they expect you to do stuff like Hadoop, it's probably more data engineering, big data developer type thing. If they expect you to do R, they expect statistics, probability, probably more data science. they expect software developer background, like maybe computer science, probably machine engineer. So I think that's where you really see the difference, is how the company structures like the job description.
Yeah, that's for sure. Totally agree there. Depending on how small the team is, it could be
Yeah.
the same job, but if it's bigger, it's likely to be more stratified. All right,
Yeah.
cool. Well, since this was a more directed question, I saw a lot of head nodding. I think we more or less agree. If any of you have any extra note, feel free to mention. If not, we can move on to the next question.
Apply for them all.
Yes. So the next question is from Reza. With all the machine learning and data science hype, do you think online courses / boot camps are sufficient to get a job in that field? If yes, how do we know the criteria for if this particular course or boot camp will help me get a job? And if no, what kind of training or education can we get besides these two that would be good to get a job? Yeah, a little long there, but essentially, is it sufficient? If it's yes, how do you figure that out? If no, then what alternative would you provide?
I'll jump right in on this. So in my opinion, I think that it's a great start, but it's not sufficient yet. I mean, it's great that you took the course and that you're taking the initiative to learn, and that looks really good. But really, employers want to see proof of what you've learned. They want to see the projects and other like demonstrable ways that they can see that you know those skills and can excel at the data science role that you're applying for.
Yeah, totally agree. I would also say that doing a course is like reading a cookbook. It doesn't necessarily mean you know how to cook. It just knows that you know the ingredients, basically. So it's just like any other field everywhere. There's a value in doing things like practicing yourself. And like she said, like having that portfolio, actually applying those skills you learned in those courses would really not only really take your skill level to the next level, it will also demonstrate that you actually really understood what you did in those courses, and it will give you more confidence in yourself. Then I felt like it's idea and take it to from start to finish. So I think, yeah, doing the practice part of things is just the extra bit of icing on the cake that would really set you apart.
Yeah. Cool. So actually, a lot of you mentioned sort of getting a portfolio, right? So one of our users, again, Jared Moore here, is wondering, so what kind of portfolio does make it easy for a hiring manager to evaluate a prospect?
When I was building my portfolio, I really valued diversity in what I was doing. I felt like it showed I had a willingness to learn whatever, even though I felt like I probably wouldn't be using, the building of this convolutional neural network on my day-to-day job. It still felt like I displayed the ability to learn something new. I thought it was exciting. And it was just another sort of notch on the belt of figuring something out. So for me, I feel like having a diverse portfolio was something that I really felt helped me in giving me sort of a range of things to talk about with potential interviewers and other data analysts, scientists, machine learning.
Mm-hmm.
I think I actually have a sort of opposite experience, that it really helped me to have a sort of deep portfolio. So yeah, I would have loved to have a range of projects, but I really, with my dissertation, my work was very deeply focused on one particular type of work, which was natural language processing. And so I think you can also be pretty successful if you have, one field in which you're really, really deeply experienced and you can talk in depth. And if you need to give a presentation, you give a presentation on that and you can answer all their questions. So I think it also helps to have, even if you do have a range of lots of different projects, to have one thing that you are really, really confident going into detail on, because you probably will at some point have to do that. And it's good to have a go-to that you're really confident about.
Yeah. Sorry.
Oh, no, go ahead.
Okay. I'd like to bounce off of both their answers and saying that the ideal portfolio would show both breadth and depth of knowledge. But of course, there's time. But yeah, I'd suggest when building your data science portfolio to select and complete projects that really interest you and that are unique to you. And I recently did a data mining project for a Forbes article I wrote where I identified the most in-demand skills according to LinkedIn data science jobs. And the most in-demand skills are Python, R, SQL, Jupyter Notebooks, Unix Shell, and AWS and TensorFlow. And then it kind of trickles off from there. So some skills I'd recommend you practice and you hone and you showcase in your portfolio are those skills that I just mentioned, and also the ability to interact with databases, especially with relational databases like SQL. That's the most common by far. Um, Also data visualization, whether it's static, interactive, storytelling with data. Like when you show off a data analysis, you shouldn't just like go through like the rote steps. You should explain what you're doing so that a layman can understand it, so that someone with no context or knowledge of whatever you're doing can understand it and come away with some new understandings. And also a really cool project to add to your portfolio would be the deployment of an application or an API. Like you can train a machine learning model and deploy a REST API, or you can deploy a nice Tableau or a Shiny dashboard. That always is very tangible to hiring managers and always looks very nice.
That's funny that you say that, Alyssa, because that was our first workshop today. We have a 3-day workshop, which is we have Rachel. She's leading an API, literally for the same reason, to learn how to build and deploy an API. I totally agree there that, yeah, very tangible work experience, or even just skills that you would learn on the job that you may not know about just from learning the concepts of data science on a course are very helpful. So on the topic of CareerCon, actually, Alyssa, we understand that you attended CareerCon last year. Is that true?
Yes, that's true.
Oh my God.
Yeah, and I could definitely say that it helped me gain my current job today. So thank you.
Really? Oh, I'm curious to learn more. How did it help you, and what was most helpful about attending CareerCon last year?
Just the wealth of advice, both the breadth and depth of advice that I
Breadth
got
and
from
depth,
everyone who spoke last year, and yeah, just how incredibly helpful it was.
That's great. Yeah, I feel like, also for my own career, I've definitely had like a few highlight events or advice from certain people in my life that really sort of shaped, in retrospect, really shaped that one step that I took that was really important, or that one piece of advice that I still hold true to today. Um, I'm curious to ask, do all of you have either someone like that, or some memory of some key point in your career, or key advice that you received that is very important for you either then or even today? So to start off, I mean, for me, I think for me, going to a certain meetups was really important. I had just graduated at the time. I had not at the time learned about other sort of what's in the industry, or what's outside of school. And one really good piece of advice I got from somebody was, make sure you learn the ecosystem in your area and what kinds of jobs are there. So going out and meeting these kinds of people in different workshops, it gave me a sense of, okay, here are the people that are hiring, here are the people that, here are the kinds of big companies in my area. And that's hard to find online, even if you're just sitting at home with the internet. So yeah, that was one piece of good advice that I got.
Okay. Yeah, I would say that the one I got, I don't even know who gave me. I think it was somewhere on Twitter. So because I had a background from chemical engineering, which is not really tech, in quotes, tech like high tech and stuff. I was really worried at how would I break into like tech, because I'm an engineer. I had no formal education in, computer science or statistics or math. And someone said, randomly tweeted, that take the first job you get in the industry you're interested in and then work your way up from there. Because my first job was in Accenture. I was in Accenture, and I was a technology consultant. I had no background in tech, and it was not data science at the time as well. But it gave me a lot of experience, like a lot of exposure into what like the general basic technology, what technology is. Like at first I was like, what are servers, what are IP addresses? I had no idea what all this stuff meant. But like it gave me a really basic, really broad understanding of what those things are. So when I was ready to move into the role I'm currently in, I already had some experience in technology as a whole. So yeah, I think that was one good advice I got.
For sure. Sometimes Twitter is the way to go, man.
Yeah, I'd like to echo both of all of the advice that you both have given so far, and also add one that I just remembered I was given early on, is to bring the same level of intensity to your communication skills as you are bringing to your quantitative and computer science skills when you're developing as a data scientist. Because really, when you're communicating your results to your manager or to stakeholders, you need to tell it with a story. You need to be able to communicate it articulately and with respect to not just like your statistical literacy and how mathematically correct it is, but also how it will impact the business. And you need to learn how to communicate well and articulate all of that very clearly.
I totally agree. Yeah, that was one of the things that most surprised me when I started out in industry, is just how, when you think about a data science job, you think, oh, you're going to be staring at a computer screen doing like intense mathematical calculations. But actually, really, most of it is working with business stakeholders and trying to convince them to use your model and to, pitch it to customers and to do all those communications tasks that you really don't practice on your way to a data science job. And I think those things, you can convey that in an interview and you can practice that, and it will totally pay off, because that is actually a big part of the job.
Yeah, really practical advice there.
I had another piece of very practical advice, which was that I needed to brush up on my SQL, because I had a mock interview sort of early on when I was with Thinkful, and I kind of bombed it because I remembered knowing the very basics, your basic queries. But then I revisited and I became a lot more comfortable with more advanced topics, and knowing those more advanced topics like cases and window functions, partitioning, that kind of thing, really makes you even more comfortable when you're dealing with sort of more rudimentary things. So needless to say, that second mock interview, I didn't fail it. And it really does show up a lot, I would say.
Yeah, no, that's for sure. And yeah, it's to say, the learning doesn't end when you get the job, right? Sometimes also very similarly on SQL, there's just some things I might not remember. I might go home and just refresh that part in window functions for, a couple hours. And yeah, it's important to know that you don't have to be an expert to get to your job where you are right now. It's fine. Just pass the interview and show that you have that capability to learn really well, right? That's really awesome. All right, another community question from Johnny McGregor. So in each of your experiences, how many interviews did you go through before you were hired at your first job? Did any of you have to do whiteboarding in front of the hiring team?
I think there's different kinds of jobs that you can apply to, and you'll get different interviews based on what sort of job it is. Like if it's a data science role where you're working with analytics, you're working with product, you're working very business facing, I think you'll get a lot more of the sort of presentation style or communicating with stakeholders kinds of questions where it seems a lot more behavioral and a lot more sort of showing off how you would work with people outside of a data science department. If you're headed more for a machine learning engineer type role, or one where you're working really deeply with models, that's I think where you're going to see more whiteboarding and very technical kinds of questions. So you can see both. It just really depends on sort of what kinds of goals you're targeting, what sorts of roles you're looking to get.
Yeah, I can say that it also varies by the company. If it's more like a FANG company or a tech company, you're more likely to encounter a whiteboard interview for a data science job. But if it's more of a finance or insurance company, or it also depends on the team too, because there's different parts of finance and insurance companies that are more tech focused or more math and actuarial focused. And of course, more tech focused teams or companies are going to have more whiteboard interviews. But if it's more math focused, or if it's like a supply chain or retail company or something like that, it'll be more math and stats focused, and also behavioral based. Typically, in my experience interviewing for these kind of positions, like the first interview is more behavioral based and like going over your resume and like why do you want to work here? Why this position? What makes you interested in analytics? And then the second interview is more of like going over your portfolio and asking you like technical, mathematical, and statistical questions.
Yeah, definitely relate to all of the answers given there. So on the sort of topic of interviewing, and maybe even beyond interviewing, for when you did end up getting your job, what were some of the biggest surprises that you didn't anticipate? I think somebody mentioned earlier that, it's not as well known that a lot of your job might actually be data wrangling, which is something that's very applicable, or very learnable, but is not something you would necessarily know until you're actually in the job on the first day.
Yeah, so I'll jump in here. I think the thing that was most interesting, maybe not as shocking, but just interesting in general, was that how much non-data science stuff you have to do the data science. You have to have meetings with your clients, have meetings with stakeholders, do your presentations, like Alison said, convince people to use your model, why your model is correct. So it's still a very professional environment, as outside just doing data science on your laptop and doing some R code and doing some machine learning models. So, and I think it's something that aspiring data scientists should also be very aware of. So there's this tendency for people to get disappointed when they first get their job, like, oh, I'm doing so much admin stuff. I'm doing so many meetings. Why am I doing so many meetings? I should be building models. I should be building dashboards, not doing all of this. But it's very important that you know that data scientists, you work with a team, especially teams outside like just data science, like more non-technical teams, product teams and stuff like that, design teams. So you need to be able to communicate to them. You need to be able to have meetings with them, really understand what they want to achieve. So, and you're just like in the whole ecosystem to deliver a very good product. So that's one thing that was pretty shocking, but also pretty liberating at the same time.
Any other takers?
No, I mean, I would agree with that. You think you're going in to make the next great, algorithm that will rock the world. But it turns out you have a meeting that could be a phone call, or a phone call that could be an email, or email that should be an actual meeting. So there's a lot that goes on behind the scenes in order to make sure that you can sort of set out to do what you want to do. So.
Yeah, it's important to know that at the end of the day, your job is still with people, and prior to the job, you might be very focused on the sort of mathematical and the theory behind all these algorithms, and that is exciting in of itself. And you will definitely have times in your job where you're at your desk looking, checking out your models, and you enjoy that sort of building. But there's a beginning and end to where that model begins and goes. So yeah, really, really good advice here. So looking back at all of your careers, is there anything, well, it's an early career, but is there anything that you would have done differently if you were to do it over? Is there anything that you would change? And if so, then what?
So I think for me, I don't know how much of it I could change, but like I said, I was pretty much in a dark room doing courses alone. And it meant that my learning time was much longer than the usual person. I would never forget that there was a particular problem on Codecademy that took me 2 weeks to solve. It was just a while loop. It took me 2 weeks to do that. And I don't think I searched hard enough for a community of people like me, maybe same beginner level type thing, or maybe it's just a little bit ahead of me to sort of give me direction. And so my learning process probably longer than it should have been. And I'm really big on community now. I always tell people that are aspiring data scientists, look for other people, look for mentors, look for people that are at the same level, have the same passion as you, to learn, because you don't want to, because it's very easy. I was lucky not to lose steam, but it's very easy when you're doing things on your own to just lose steam and just close your laptop and like, I'm going to do something else with my life. Yeah, so if I was to go back in time, I think I would be more intentional about getting a community of people to work with.
Yeah, I'm with Rosebud. I wish I would have joined a community or found a mentor sooner. I started really in like 2014 or 2015 with my analytics career. And in 2016, I decided to join Twitter, to join the RStats community, hashtag RStats, and learn more about R for my research and for my job. And as soon as I joined that community, my learning went like this. It went exponential. It was crazy. Like 2 months of Google searching could be solved in like 2 minutes of asking a question on Twitter, just like looking on Twitter under the RStats hashtag. And the support of that community is phenomenal. There's R ladies, R forwards that welcome underrepresented groups, and it's the epitome of a healthy tech community. I recommend you check it out. But yeah, as soon as you can, if you can learn with a community, join a community. It makes it so much smoother for many different reasons.
Yeah,
I
and
totally agree.
sorry.
Oh, go ahead.
Sorry. So one thing I'll add to that is that I see that the fact that I did a lot of stuff on my own affect me till today. So I work with a team of people, but I have a tendency to just be in my head. I want to solve it myself, right? And it can take me 2 hours to do something when it could take me an hour or 30 minutes to do it if I reached out to somebody else in my team. And I have to actively like come out of my head and say, Rosebud, you have a team of people that are here to help you. Like you can't spend 2 hours on something. Like you should reach out to people that have experience in it. So I think that's one place that is still affecting me till today. And yeah, I think I should have done that much earlier.
Yeah, totally agreed with everything everyone said so far. I mean, I feel exactly the same way, so it's kind of creepy. But one more thing that I would add too is something that I've learned on the job that I wish I'd learned much earlier is to get to a minimum viable product fast. So this is something that, you know, if you're in a workplace, you have to very quickly show that what you're doing is going to pay off down the line. But I wish I'd had that philosophy when I was just trying out, learning new things. If I just tried to, you know, build a really quick app to try out this new model that I was learning how to use, I think I would have learned a lot faster, because you tend to learn faster when you're, you know, when you have a goal, when you're building something, when you can see the results, show your friends. So I wish that I'd learned that earlier in my career, because it really does make learning easier and it makes you more successful when you're on the job.
Mhm. Yeah, you know, working with a lot of different stakeholders seems like such a big part of all of your jobs, and I think it really, again, speaks to the fact that the best data scientists might not always be people that are have just been doing that their whole lives, but have been able to really get a sense of all the different kinds of people, how other people and teams may think, and how to really collect those incentives and initiatives together to come up with a product that's meaningful for everyone, right? Really great stuff. And again, love the synergy here. I think whenever we have these kinds of talks with different panelists, this is exactly what helps the community learn more. A lot of this stuff is not on the internet or on paper, and it really requires just asking people face to face to start gathering this sense of collective sentiment. So really great advice here today. So let's finish off with one last question, looking off into the future. So community member Taylor Hintz asks, right now, deep learning / AI and advanced statistical modeling techniques such as XGBoost are on the cutting edge of predictive analytics. For very competitive companies, these are incredibly important tool sets. But like many other statistical packages before them, they're just the current leaders. What do you think will be the next need-to-know technologies and techniques? What about the future of unsupervised learning? That is a hard question. I think that for me, I'm seeing this sort of democratizing of machine learning and AI. It's not so much, so, you know, if we start off with a field and everybody is working from packages from straight in the code, that's sort of, I think, the beginning of it. And it's great that we have so many experts such as yourselves in that this day that can go deep into the code. But like you said, it very quickly comes back to stakeholders and other people in the company. And how do we best communicate these sorts of tools and strategies to them? I'm seeing sort of tools arise these days, such as, you know, AutoML and things like that. that's sort of trying to make it easier for everybody to understand how that sort of stuff works. So at least for me, without being able to predict the future, I feel like that's sort of where I see things going. Deep learning and AI and ML are going to become easier and more accessible to everybody to understand, as opposed to the other way around. At the very least, I would hope so.
Yeah, definitely. AutoML and Data Robot and those types of technologies have caught on very well at our company. We're a very risk averse, as many insurance companies are. And yeah, just being able to develop all of these models with the added transparency of variable importance and other metrics like that has really driven our movement into more machine learning models. Also, the use of unsupervised learning like PCA. At first, managers were like, "Oh, it's something new. I'm kind of scared," but yeah, like once we demonstrated how it could lead to more accurate both GLMs and machine learning models, then we got more on board with it, and we're like, "Oh, this is really cool. We should start using this and start embracing this new technology and this new math."
I think for me, what I'm looking out most for, and because of this trend where AutoML and lots of packages that are really well built make it very easy for anybody to just sort of indiscriminately apply machine learning, I think the next step is sort of thinking through: are we applying this correctly? Are we applying this with biases and with different kinds of ethical constraints that we need to start thinking about, especially as you apply it in fields like insurance and in policing and prison, all kinds of applications where there's, real human consequences. So I think as machine learning becomes more democratized, there's also going to be pushback where you have to make sure that, just because somebody knows how to apply it, are they applying it correctly? Are they applying it ethically, responsibly? So I at least hope that that's one of the things that comes along with this new trend of AI being everywhere.
Yeah, really good point. With great power comes great responsibility, right?
Yeah, I would agree. I feel like there's been a big push for automating data analysis. So the next frontiers are definitely going to have to be sort of secure deployments. And that's something I feel like we've seen a lot of in the news recently, with lots of data breaches on X company. Am I allowed to say that on air? So I feel like that'll be certainly the next frontier, which will be sort of securing networks, sort of locally as well as on the cloud. And I feel like that should be the next big push, is how can we do these things securely? And I feel like that'll be super important.
Mm-hmm. Yeah, really great.
Yeah. Yeah. So on the back of Allison's points about using machine learning correctly, I think as machine learning really comes into every part of our lives, I think they also see increased policy making for data and for how machine learning models are used. You can see stuff like GDPR, for example, and we'll see a lot more of that, where people are more concerned about their privacy, also concerned about how we're using the models in our everyday life. For example, things like you said, like policing. So you're talking about basically revising the law. Do I arrest people for intent or for their actions? And would I allow them to do their actions first? And does that harm somebody else? It becomes very complicated, and you can see a lot of policies changing because of how machine learning affects our everyday lives.
Yeah, definitely agree there. Well, with that last question, I believe that is the conclusion of our panel. Thank you all so much for being here today. All four of you, Rosebud, Alyssa, John, Allison, thank you so much for being here. We got lots of great questions, I feel, really good, great discussions. And again, the sort of common themes and agreements that came up with our pods. I hope and I'm sure it'll help many that are tuning in and listening. If you had any more questions to ask and didn't get to see it here, or wanted to follow up, those of you in the Slack channel, the four speakers will be there to answer some of your questions and hang around a little bit afterward. Otherwise, yeah, thanks for tuning into our panel. We will have a short lunch break now and come back at 1 p.m. PST for a talk with Jen Wang on demystifying the transition from PhD student to data scientist. Thank you all.
Thanks, Jessica.
Welcome back to CareerCon. I am Jessica, and we are back from our lunch break and here with Jen Wang to talk about demystifying the transition from PhD student to data science. Coming out of academia into data science is another common challenge many people face, and with many uncertainties. How much coding experience do I need? Am I making a big mistake abandoning my PhD discipline to go to a new career? Jen Wang is here to give her expert take on those topics. Jen is currently a data science manager at Wayfair. She received her PhD in physical chemistry from the University of Iowa. She has since successfully navigated her way from academia into data science and is currently leading a data science team to support direct mail and display programs at Wayfair. Take it away, Jen.
Thank you, Jessica. I'm really honored to be here as a speaker. I'm a big fan of Kaggle. And to everybody who's listening, good afternoon. I hope you are enjoying the career event. I still remember 3-4 years ago, I was at similar career events, wondering what my next steps would be. It's definitely very different from what, like, my career today is very different from what I imagined. And having made the transition myself, I like to share with you what happened in my journey and some lessons I learned and some additional tips for you. Let me start with my own journey. I was going to, so when I was a child, I was really interested in science. So especially I wanted to be a scientist working in medicine and health field. That's why I got a PhD in chemistry and then did drug design research for my postdoc. I was hoping to become a professor and solving some really challenging research problems and someday win the Nobel Prize. Well, that didn't happen, because I became a little confused and I started wondering how much impact my research was really making. To give a little background, I was doing drug design to cure disease. That is a very bright end goal, but my everyday research was very basic. Even if my research is successful, there are a lot of downstream questions that need to be answered before a drug candidate becomes available in the market. So even if I'm lucky, my molecule would be available to help someone else's life in 20 years. And as I grow older, it just becomes more and more important for me to see faster turnover on my work. I want to make more immediate impact. And also, I became more interested in disease prevention rather than treatment. So I just became more and more unsatisfied with my own work. And that's how I started beginning to explore other opportunities outside my domain. This is how my journey actually looks like. I started as a confused postdoc, not entirely sure what my next step would be. So I just took some time to do some self-reflection, keep asking myself, what do I really care about? And then I started to learn on my own by Googling and also going to seminars and conferences. And after some time, I came up with the idea to combine metabolomics and alternative medicine to understand health better. And I even wrote a research proposal based on the idea, which didn't get funded, as you might have guessed. But because I was working on this proposal, I got exposed to many tools useful for solving that problem. And one of the tools was deep learning. And I started learning more about that field and became really fascinated. So I started to take classes online in data science and machine learning field, which eventually led me to offer from Insight Data Science program to join their health data science program in Boston. So I moved to Boston hoping to find a health data scientist position in industry. But eventually I ended up at Wayfair, which was unplanned. I can elaborate on that, but just briefly, I was introduced to many different employers in the field when I was at Insight program. And I really liked people I talked to in Wayfair, and I became interested in the business challenges they were trying to solve with data science tools. And also, it's just a gut feeling that Wayfair is a good place for me to learn more and also reset and try to learn something totally different from what I've been doing in my life, which can give me more like fresh perspective to how to solve problems. So I landed my first real job as a marketing data scientist at Wayfair. And now I'm a manager leading the data science teams that support the display and direct mail marketing at Wayfair. Having come this far, I have a few lessons to share with you. First is there will be a lot of barriers and uncertainties in the career development path. Some of you might be thinking developing a career is more difficult, but not that different from what you do in school. If you have a very clearly defined goal and you work hard, you will be there in maybe a few months. But in reality, nothing works that way. You do need to make plans, but more importantly, you want to take actions early, because until you get out there and try out all the different paths, you never know what part of your plan would work and what kind of barriers you would hit, and also what kind of new opportunities would arise as you continue to improve yourself. So it's like working in a maze. You just have to like try many different ways to make things work out. Take me, for example, I didn't plan to become a data scientist. All I had was a research idea that I was really passionate about. And I was just like learning and trying to explore all the different options, which eventually led me to the data science field and my current position. So make plans, but more importantly, take actions early and expect all these uncertainties and keep an open mind to the new opportunities. The second lesson I learned is, in order to find your sweet spot for career satisfaction, you really need to align your passion and your skills with market. This is the lesson I wish I learned earlier in my life. When I was younger, all I cared about is I want to do what I love. I really like, I was passionate about drug design and treating disease, and I was good in the lab, but I didn't consider the market because I was young and not smart, I guess. But this is fun because I was poor, but at least I was happy. But as I grew older, my interest shifted, and now I'm poor and unhappy. So even though it felt like a shame to throw away everything I learned in the drug design field, it still makes more sense for me to move out of that area. So if you are in a similar situation, if you feel like your interest has changed, you no longer like what you did, so just accept that fact and take a step back, really think about what you want to do right now. And one resource I recommend is the Live Your Legend Discovery Pack. You can Google and find it. This helped me in my most confused time of my life. Or if anybody has any use for resources, just share on the Slack channel, and we can you can try to explore all the different ways. And another lesson I like to share is you want to choose the right industry and company that can help you accelerate professional growth and maximize your potential value. We have a Chinese idiom, 水涨船高, which means as the water rises higher, the boat naturally floats higher. I'd like to borrow that concept here and think of industry, the field, as water, and the company is a boat, and we are like sailors riding on the boat. So you want to choose an industry that has a very promising future, like data science is the right call, and also the company that give you the opportunity to grow fast. For example, I think I have learned a lot more and grow much faster in the past 2.5 years since I transitioned from a chemist to a data scientist. This is not only because data science is a much faster growing field, but also because I joined Wayfair. And Wayfair had that, Wayfair has that supportive environment to enable me learn more and do things faster. And after I became a data scientist at Wayfair, I've got a lot of questions from PhD students and postdocs with similar background. And through the conversations, I've realized there are some misconceptions about what it means to be a data scientist and how to become one. So I like to share this here. The first myth or misconception is coding is the most important skill for a data scientist. This might be true for some of the data science jobs, but definitely not the case for many data science positions in industry. Especially at Wayfair, we don't just sit at our computer, wear earphones, and code all day to get the machine learning solutions. How we work is we form cross-functional teams with other business partners to solve business challenges together. It is important to be able to code effectively, but there are also many other skills required to perform the job well. For example, as marketing data scientists, we are thought partners with our marketing stakeholders, and we meet regularly with them to analyze the campaign performance and brainstorm project ideas and prototype business solutions. We need to communicate our ideas and models very effectively to many other teams at Wayfair, and some of the people are not technical. Also, in my opinion, data scientists are still called scientists because they share some common qualities as other types of scientists. For example, for sometimes I think be able to think through the problem critically and creatively is more important than coding and implementing the solutions. Also, as you climb up the ladder in your career, roadmap planning will become more and more important part of your job. So all of this would require other skills than coding. And just to give some examples of core qualities of a data scientist, you need to be able to understand all the pros and cons of common machine learning algorithms and have the business acumen to understand non-technical challenges and perspectives. And also very important to have critical thinking and problem solving skills and attention to detail in order to discover nuances in data. There are so many examples I've seen in Wayfair that just paying attention to some detail how the data is processed has made big breakthrough in our workflow. Also, excellent communication skills and be able to collaborate with many different teams at your company. Compared to coding, these skills are much harder to acquire. And I think that's the reason why PhDs are very highly desired in many industry data science jobs, because just on average, we've seen PhDs usually have these qualities just out of their PhD training. This brings us to the next point. Some people wonder how much their PhD are still valuable if they transition into a new domain. So when some people heard I transitioned from a chemist to a data scientist in marketing, their first question is, do you regret to get your PhD in chemistry? Because now it's not valuable anymore. I mean, it's not useful for your job. So if they met the PhD title, then I agree, because the PhD title just means I know a lot about nothing. It's a very narrow subject. So that would not, knowing a lot about a specific domain of chemistry does not transfer into other domains. However, I think I've learned a lot of other valuable skills other than the domain knowledge and skills. To me, I think earning a PhD is a tremendous character building exercise because all our dissertation research are unsolved problems, and maybe there's just no solution at all. And you just have to keep pushing the boundaries and try harder and harder. Not sure about you guys, but I feel like my experiments fail 90% of the time. So I was really frustrated in my first few years of PhD. And but because of these failures and frustration, I learned to really carefully design my experiments and think through a problem critically at the beginning, and also think outside the box to find creative solutions. Also, when my experiments kept failing, my PhD advisor was very patient with me, and he was very supportive and provided a lot of guidance. So from him, I also learned to be patient and persistent, and also how to handle stress. And this, I think in my mind, these skills are much more valuable than the domain knowledge. And these are things you can carry with you into any new domain. I feel like the PhD training really enabled me to ask the right question and solve any challenges in any new domain. And I just feel I've become a much better person after my PhD training. Myth 3 is companies don't give you the time to learn new things. When I started considering a career outside academia, my biggest fear is I will lose the fun of learning, because my impression about the industry job is to use whatever you already know and work hard to solve whatever problem your manager gives you. I know a lot of students have the same impression, and having worked in industry for more than 2 years, I can now happily report back to you this is not the case. As a matter of fact, I think there are more learning opportunities in industry because companies usually have a structure to help their employees learn at work and improve their performance. Take Wayfair as an example. Our data science teams have weekly team huddle where a member does a deep dive of their project, just outlining the research problems, what method they are using, and try to brainstorm together with the rest of the team. This is very similar to our lab meetings in academia. There are more than 100 data scientists at Wayfair, and every month we have all hands meeting, where a sub-team would give a dive into their work stream, talk about the business problem, also the method they are using. This is very similar to the department seminars we have in academia. And also there are company-wide journal clubs and lunch and learns to discuss research fresh out of academia, or some tools that can be useful for many people. And this is similar to the university-wide seminars and workshops where you can acquire skills outside your immediate working domain. In addition, Wayfair also has Learn at Work, which teach employees not only the technical skills, but also the business and management and leadership skills. You also have feedback constantly from your manager and peers, and there are also mentor program. I don't think these opportunities are available in academia, especially training and coaching in business skills, unless you are in a business related major. So I think this is why I've learned a lot and made more progress over the past 2.5 years than any of the years I spent in academia. Another question I hear a lot about PhD students is whether they should do a data science bootcamp in order to transition into the data science field. For me, I participated in the Insight Data Science program. It is very helpful for me, but I suspect it's not absolutely necessary for everybody, especially for those who are ready to make the jump. So instead, what you should ask yourself is what skills or opportunities you are lacking. You can bridge most of the skills on your own. It is harder, but it's possible. For example, if you need practice on the basic coding or machine learning and data science skills, you can just take classes online or practice in Kaggle competitions and Google for solutions as you go. If you are thinking about getting critical thinking and problem solving skills, unfortunately, I don't think boot camps can help you with that, because this is the true value of PhD training. And these skills really take years of practice to get. And if you need help with communication skills, you can join Toastmaster Club or just find more speaking opportunities like at conferences, department seminars, or even just lab meetings, and make a conscious effort to improve. And for business acumen, you can find business cases to practice online or joining the consulting clubs at your university. And for networking opportunities, there are a lot of meetups and conferences. You can also join LinkedIn groups or just connect to others through Kaggle competitions together. Then you might ask, when should I consider a data science bootcamp or a data science program like Insight? So first of all, if the program you are considering is just to help you improve the coding skills, then I think you can avoid it because this is actually the easiest skills to pick up on your own. But if you do need some polish on some skills, you might consider joining a more sophisticated program like Insight Data Science. And I can give you a little personal perspective why I think Insight Data Science helped me. First of all, I was working in a chemistry field, and I did have some coding experience, but mostly I was an experimental chemist, and the problems I work on are very far away from data science. People around me were actually not even aware, like 2 years ago, 4 years ago, when I mentioned data science, at least they were not like even aware of that. So it is very hard for somebody like my background to prove out on my own that I'm ready to take a position in industry as data scientist. I think that's one of the reasons why Insight Data Science was helpful in my case. Secondly, I think the program was pretty well designed. So they put fellows with similar mindsets but complementary skills into one room so that we can learn from each other. And they also provide the resources for us to develop our own data science project or the opportunity to work on a consulting project. So it's really, also they help you polish the presentation to pitch your project to the companies you are interviewing at. So they really gave an opportunity for us to develop a data science project end to end, from ideation to delivering a data product. And also, I think the most value I got out of the program was network. I know now I have a high quality network of top-notch data scientists in industry who I can turn to with very challenging problems. And also, another reason you might want to consider a program is you really need someone else to monitor your progress. And finally, I have an additional piece of advice of how to launch a career in data science, which is build your own project. Once you have a basic understanding of all the different machine learning algorithms, you find the problem not to do in your life, because then you will be super motivated to solve that problem, and nothing can stop you. And before you know it, you will make a lot of progress. And also because everybody's dream project is different, it would be a very novel, original research idea, and it adds a personal story when you bring it to your interview. And a bonus point is you'll become very effective at Googling, which is a really valuable life skill. To build a project to showcase on your resume or interview, you really don't need it to be complicated. Your dream project might be very complicated, but you can find, maybe you can break it down into small steps and just start with the first step. Build a MVP project or something small that's relevant to solving your problem. For example, I was really interested in combining metabolomics and the alternative medicine to understand state between health and disease, which I call a sub-healthy state. But that would involve a lot of different domain knowledge and also a lot of data, which is hard to find. So the research might take 20 years. What I did is, because I know I cannot solve the problem immediately to showcase on my resume, I just built something very simple. I just look at where people are tweeting about alternative medicines, what they are talking about, and also their sentiment. And this actually brought me to the Insight Data Science program. So you can also build something as simple as this. And this is all I want to talk about. I want to take the opportunity to thank my postdoc advisor, Professor Wen Xuan. He's just the most diligent scientist and most amazing person I've ever met in life. He was very understanding, and he showed full support for my career transition from the domain that he's familiar with into a domain he really doesn't know much, but he was super supportive. And also thanks to Wayfair and the data science team for a very inspiring learning environment. I know I owe all my successes to Wayfair and the data science team. And I used the presentation template from Slides Carnival and illustrations by Andrew to make this presentation. So thanks to all the people who made and released those resources for free. And also Chris Hoy at Wayfair for feedback on my slides. And finally, thanks to everybody who's listening. And I'd like to open the floor for questions.
What a great presentation, Jen. I personally resonated with a lot of the advice you gave on not just practical job seeking advice, but also like attitudes and sort of questions to ask yourself that really go beyond just getting the job. So thank you. Is a PhD needed for data science is a really common question that I get even in my own everyday life. And I think your perspectives were really well articulated and spot on. So with that being said, yeah, let's move into answering live Q&A questions from the community on Slack. Our first question is from Moyo Ajayi. And Moyo wonders, what are some of the ways PhD students, particularly those lacking in work experience, can highlight their skills when applying for data science jobs?
Yeah, so what a trick I used when I was applying for a job is to read the job description and highlight the requirements and then think what is in me that match those requirements. So it can be simple, like for example, if you have worked on a project, then think about what kind of skills, what kind of tools you have used, which might be relevant to data science. And also, have you presented this work at conferences? Have you written papers on that topic? So then that also can showcase your communication skills. So you can use like just like take a step back and look at the job description, think about what skills you have that's relevant.
Great. Next question is from Rashab Sharma. Hi, I am a current master's student and I will graduate in May 2019. I have a PhD offer and at the same time also a full-time job offer for ML. My question to you is, at this critical point, would your advice to be to take the PhD offer or the job offer? Also, did taking a full-time job after your PhD help you better in the career more long-term, or do you think taking the job would have just been fine as well?
I think there are a few aspects. To me personally, PhD helped, but I think that's because I wasn't good enough before taking the PhD. But for you, I think you can think about, as you mentioned already, the long term. Does the PhD, I don't know what field the PhD offer is, but think about how this would help you in the long term, but also consider the market, right? In maybe the PhD, you think it will help you given the current job situation, but in 5 years, does it change? The area where you are going to receive PhD, is the job market going to be saturated then? If that is the case, does the PhD training give you additional skills you can carry over to any of the other fields? But I think also most importantly, you should consider what your calling is, like what your heart desire. So does the job offer for machine learning give you the opportunity to do what you love doing, or like it's not as compelling compared to the PhD. If it's the first case, I would definitely take the full-time job offer, because at least like you are going to earn more.
Great. So our next question is from PLN Reynolds, and PLN Reynolds has 2 questions. The first question is, how did you frame or pitch your dissertation research to potential employers? Did you feel like it was perceived as a strength that you had a PhD?
So I think I first want to correct maybe another misconception. Like people think, oh, industry are only hiring PhDs for data science position or senior data science position. It's not because of the PhD title. Again, it's because just on average, like PhDs are better trained to be able to think critically and creatively. So as long as you demonstrate that in your job interview, whether you are PhD or not, if you are prepared to answer those questions and show you are really a person with those skills, then you'll be fine. So thinking back at my interview, I don't think there was really emphasis on, oh, I have a PhD. It's more about they're just like pressure testing, whether I'm asking the right questions, whether I'm thinking with them at my interview.
Great. And then the second question coming off of that is, how did you find mentors or a network more generally that helped you along as you transitioned into industry?
How did I find mentors? I'm just trying to think. Yeah.
And the context for this question is that, you know, most PhD advisors are great at advising future faculty, but perhaps have less experience with non-academic career tracks. So in that case, you know, who do you go to for this sort of advice to help you go into that field a little more smoothly?
Oh, you mean how to find a PhD advisor that will help you transition into the data science field?
Not necessarily PhD advisor. It could be other people as well.
Anybody. Yeah. So I don't remember. I don't have particular like mentors, but I did like reach out to people when I read about their research paper and then had the specific questions. And also I went to conferences. Even I didn't want to be a pest, like asking like very asking questions to everybody. But even if like at the conference, I talked to someone who provided insights, just that 5 minutes is a valuable mentorship for me. So I think rather than thinking about how to find a mentor, you might want to just like get into the field, talk to many bright people and get their ideas and their advice.
Great. Next, we have a user called Feng. Feng says, I have a PhD in cognitive neuroscience. I have been a postdoc/research scientist for 7 years now, and I'm now a programmer and data scientist at a university. Working on certain kinds of data within research, I presume. I wonder, what are the next steps I should take if I would like to get a data scientist job in a really large company? Do I still need to obtain, say, a data science certificate, master degree? And also, not sure if you can speak to this, but would age matter in this sense? As in, if you're a non-traditional PhD student, your age could be more than the traditional 27, 28 when you're out. And the question is, would that matter as well?
So I only speak for Wayfair. I do not think age matters. So it's more about your skill and your work style, whether whether you can solve problems, whether you can work with others. These are more important than anything else. Regarding suggestions for the next steps, I think you have like a neuroscience background, which is much better than my chemistry background. It's more relevant to data science, and you are already a data scientist. I would say if anything, you might want to polish your communication skills. Again, I don't know, like maybe you are also already good at that. So I would just like, if you are really interested in a data scientist position, I would just apply and see what happens. Because even if even if it doesn't happen the first time, at least you get some feedback and to understand how maybe why I didn't do well at interview, which skills I still need to polish. It goes back to my lesson, like go out there and try.
Yes, that's for sure. And a lot of great questions here and more to come. So our next user is Arun Chandra, and this user is wondering, I found it hard to get into the Insight Fellowship program for the past 2 years in spite of having experience in programming and some hands-on experience in ML in my research. Do you have a sense of what is the most critical aspect they look for in candidates?
You probably want to ask the program directors, but I think my 2 cents, your hard skill like programming is like it's like a bar you can enter, but more important they are looking for like whether you have done independent research, then you can think like critically and also creatively, and also your communication is very important as well. And if you haven't done so, you should try to build your like personal project, because I think that is, for me, that was like the final reason I got in. And also to add more flavor into the story, I applied 3 times before I got admitted into the program.
That's really good context to have. I think in a lot of these, even in boot camp situations, sometimes it takes it takes many tries. Good insight there. Our next user is Nelly Tacheva, and Nelly wonders, what does a manager of data science teams need, such as things to look out for leading a team of data scientists? Nelly's situation is that he or she is transitioning from software development to data science.
So what the question is about?
So if Nelly were, if I were to lead data scientists, what would I need to know or have or do?
Oh, that's a very broad question. Like there are many things you would have to consider. So one is there are a lot of so how to lead a data science team. It might depend on the industry and even on the company. So as a data science manager myself at Wayfair, my key job responsibilities is to understand what our marketing stakeholders need. Really understand their priorities, their roadmap, and be a thought partner. Like really, even maybe they need one thing, and if I understand what they really need, I can suggest a more productive path, or like just brainstorm with them together to get to the end goal faster and more efficiently. And secondly, for your team, you want to lead a team of members who who are all like motivated to do their work, but also like have I think it's best to have complementary skills so that they can all learn from each other and help each other to make the work more productive. So the other thing you want to consider is if you have multiple work streams, really connect the dots. Maybe like you can they have a common theme, and you want to avoid reinventing the wheels. You want to avoid duplicating work. So maybe you can prioritize one type of modeling in one work stream and then let the others adapt, and then the other type of modeling in a different work stream. So these are like all considerations.
Great. So this seems like a pretty common question here from our user, Jat. Hello, Jen. I am a postdoc in theoretical particle physics. I'm looking for opportunities outside academia to build my business acumen. What would you suggest doing to build my business experience while I am a postdoc?
So I think there are consulting clubs in a lot of universities. You could join that. What they do is they have some business cases to work on together. I think there are also like online resources. If you search like practice business cases, you can find some of the resources I think one way to do that is find other people who have similar goal and form a group and practice together and provide feedback together.
Great. A lot of great questions here. We have one last question from Mike Lane. What is it like to work at Wayfair? And what is your most favorite and least favorite thing about your job?
My working on Wayfair, as I said, is very dynamic. I really enjoy my favorite part is people I work with, not only on the data science team, but also our stakeholders, our partner teams. Everybody is so smart and so humble at the same time. Like sometimes we even have different in opinions, but nobody takes it personally. We take our work seriously, but never take seriously of ourselves. So we sometimes we try to come up with a solution together, and it's just a lot of fun. Least favorite, I don't think I have any. I'll get back to that if I think of any, but so far I'm really happy with it.
That's great to hear, Jen. And I feel you on that. Having great people on your team is one of the best things to go into work for.
Yeah.
Well, with that being said, our session has come to an end. Thank you all so much for tuning in. And Jen, thank you so much for being here. I think we got a lot of great questions today and a lot of great discussion points. So hope that people have found it very useful.
Yeah, thank you, Jessica. It's a pleasure.
Right. Yeah, you're welcome. And if any of you still have any questions for Jen, Jen will be hanging around in Slack for a little while afterwards, so you can ask her some more questions. And yeah, without further ado, we'll end the session with the next session beginning at 2.
Okay, thank you. Bye.
Bye.
For our last session of the day, I'm happy to introduce Kaggle's very own Dan Becker. Dan's a data scientist with a PhD in econometrics and serves as the head of Kaggle Learn. Dan will be doing a little bit of his own introduction here in a moment, but in the past year and a half, he's helped create over 10 data science courses on the Kaggle platform. Dan, like me, is from Denver, Colorado, and he's not doing or teaching data science. He enjoys skiing, climbing, and playing tennis. And a fun fact, he's referenced in an episode of the TV show, The Office. Dan, I'm gonna hand things over to you to help us understand how might skill building be holding us back. Dan, take it away.
Okay, so before I get started, this is a topic which I think is transparently from the title, many people will find counterintuitive. Some people may even react pretty negatively to it. So before getting started on the topic itself, I just wanna give a brief heads up on the experience or the data from which I'll be drawing, so you can figure out whether you wanna believe me or not. So I got a PhD in 2009. By the way, so getting a PhD is not any part of why one should believe me, and that's not a piece of data at all. But I did spend a year or so after that where I got a job working for the US government, but I was looking to live in a specific geographic area and spent a long time trying to find a job as a data scientist. Really struggled with it for a while. So I have been through the data science job search experience. In 2010, I had the hypothesis that if I started competing in Kaggle competitions and did well, that would advance my career and help me find the job I was looking for. I had the good fortune to do well and get to test that hypothesis, and it worked out really great. I finished in second place in a competition, and as a result was contacted by a large analytics consulting company that hired me directly to do a few things. So first, create trainings for their analysts or their consultants. Second, to help them build out their capabilities. So in that role, I interviewed hundreds of junior data scientists and data scientists, and then also to talk to their clients. So I got to see inside the data science and analytics departments of quite a few large companies, disproportionately in the US. I think there are 5 companies in the Fortune 500 that I worked with and got to see how they think about data science, which has really, I think, given me a lot of perspective on the field as a whole. In 2015, I taught a data science boot camp. This was a 12-week course where I taught people who had not done data science before how to learn data science and how to do data science. All of them got placed in jobs, typically pretty good jobs. So some at large companies like Amazon, some at small companies like a startup that's doing deep learning for radiology. But I've had the good fortune to see their progressions and not just in their first job, but I stay in touch with them. And so it's another way that I've gotten to see different ways that people grow as data scientists. In 2017, I joined Kaggle and started Kaggle Learn. That now has between 25,000 and 30,000 users a month who do our hands-on coding exercises as part of our courses, and more than that, who just read and follow along in the courses. And I try to not in a interpersonal way because of the number of users, but I do try and keep tabs on how people are doing. So I think between all of this, I've seen a lot of different parts of the life cycle of a junior data scientist. Probably interviewed in total between all my jobs, probably 500 candidates. And one of the things that I've seen is you have a spectrum of different ways that people approach getting their first or second job in data science. And I'm going to simplify that spectrum of approaches a little bit and talk about 2 different personas which are on opposite ends of that spectrum. So the first I'm just going to call short-term Sal. This is someone who is just looking to get a job, wants to do it quickly. They're going to do whatever it takes to impress an employer, but they're not thinking too far out. Most people I know who fall into this profile are reasonably disciplined, but they're looking for, like, they have goals that they want to reach in a matter of months, not years. The other end of this spectrum is someone who I will, in this presentation, refer to as long-term Lee. So Lee is someone who is willing to study hard, study things that are pretty foundational, try and develop a deep theoretical understanding, is quite disciplined about it, and has goals of, I want to be a great data scientist and have a great data science job, not in a matter of months, but I'm really focused on where I'm going to be 5 or 10 years out. So if the world was a real fair and predictable place, we would expect their trajectories to be something like this. Short-term Sal would do better in the short term, and at some point, long-term Lee, who invested a lot upfront to get a deeper understanding, would surpass short-term Sal and would have a better long-run achievement. So that would both, in some sense, be both of them reaching their goals. This is, of the people who I've seen, I don't see this pattern, which we would expect at all. And I should say, like, it pains me a little bit, the pattern that turns out to be the case in real life, because I think my personality is a little bit closer to long-term Lee, and that's what I did earlier in my career. But in practice, the pattern that we see is closer to what you see here, where short-term Sal and long-term Lee, maybe they start out in similar places, but at some point, short-term Sal gets a job. However much time they were both spending on learning data science or projects on the side, short-term Sal now has 40 hours above and beyond that doing data science because short-term Sal is getting paid to have a full-time job doing data science. And even beyond that, short-term Sal now has colleagues and a manager who are really invested in their further growth and improvement. And so short-term Sal really, their knowledge improves faster than Lee's, and their achievement, they're sort of always ahead of long-term Lee, who invested in some really like foundational understanding of data science. So like I said, it pains me that that's the case, but I do think I have a good explanation for why that's happening. So the first part is, if you look at the things that long-term Lee does, they're either studying textbooks, which takes a long time, or they're taking online courses, and most online courses. So I have a couple of screenshots here: Fundamentals of Statistics, Fundamentals of Machine Learning. These, by the way, are courses I've not taken. I assume they're both taught by very capable and smart instructors. But if you look at them, they so let's look at Fundamentals of Statistics first. That is 16 weeks, so 4 months, at 10 to 14 hours a week. And for many people who have either other jobs or other commitments or other studies, like 10 to 14 hours a week is hard to keep up. And then you're saying, even if you can do that, even if you can keep up, just this one course is 4 months. The Machine Learning Fundamentals course that I posted here, that is 8 to 10 hours a week for another 10 weeks. So just to finish these two courses is half a year. If on the side you're studying a textbook, trying to learn machine learning through textbooks or linear algebra through textbooks, you're really like quite far out, many months out, where you're still doing things that you think of as fundamental learning. And unfortunately, like even while that learning might be valuable in some ways, the phenomenon that I see of people who take this approach is they study a ton. They're not really sure when they've reached a threshold where they should feel qualified to start a job. At some point, they say, "Oh, I'm sick of studying and not applying for jobs." So they apply for jobs, and then they hear nothing. And studying these core ideas, not having helped them achieve their goals, they, instead of changing path, they instead say, "I'm going to double down on studying. Maybe I just didn't study enough." And so they just repeat this cycle. And I know people who have gone through this process for literally years, which at the end they're pretty frustrated, and I think justifiably so. And from the outside, like it's quite disappointing to see talented people working hard and achieving so little. But I understand, having hired quite a bit, I understand why they're achieving so little. Primarily, their resume is in a stack of quite a few resumes. So of the times that I've hired, so let's see, there was one point where we were hiring for 5 or 10 open positions, and we got over 1,000 resumes. So if you've taken some MOOCs, like, are you going to get noticed in a stack of 1,000 resumes? Or if you've read some textbooks, like, is someone going to say, "I think this person really stands out"? No, it's just, you're just going to get lost in the shuffle. And that's what happens. And so people can be going through that cycle, getting lost in the shuffle for a really long time, which, like I said, is quite frustrating. I want to, so part of it is that you don't get noticed because it's a crowded space. There is a second part of it. And this will be like the one data science brain teaser that I will walk through in this presentation. There is a part of it that is where companies are justified in not finding those employees and putting them at the top of the stack. And that is because there are certain skills which just aren't taught well in textbooks, tend not to be taught well in MOOCs, and are like super practical skills that are important. You learn them doing data science, but there's not like complex linear algebra to them. And as a result, they just seem to get glossed over in most treatments and in most courses. So let me give you an example. So when I was teaching that 12-week-long boot camp, this was an example that came up. We had data from a ride-sharing service. The ride-sharing service wanted to build a model where at the beginning of each month, they could predict who's going to keep using their service in that month and who's not going to use it. So they set up the data so each user shows up in their data only one time. And then they have something we want to predict, which I've listed here as continued use. It's either true or false. You have a bunch of predictors or features. These are shown as ... And then we have one particular feature, which I'm going to show you, and I'm going to go into in the next slide, which is the average rating that that particular passenger from that row gave to the people who drove them as part of that ride-sharing service, like Uber or Lyft. Okay, so the phenomenon that we saw is shown in this slide, and this again is not the real original data, but it shows the relevant phenomenon. And I'm going to tell you what I see here, and I want you to see if you can figure out what's causing this. So what I see here is if you look on the graph on the left, this is a histogram of average scores for each of the passengers who stayed. So those who continued using the service in that raw data, we see that a lot of them gave their drivers ratings that were sort of in the middle of the distribution. If you look at users who quit using the service, you see, yes, a lot of them gave ratings that were in the middle of the distribution, but you also see some that are at the bottom of the distribution. That's this one, and you see a good number who gave ratings at the top of the distribution. So of users who gave very low ratings, that's the users who rated at 1. They rated their drivers 1 on average. Like, it's understandable that they quit. All their experiences were bad ones. But it's kind of puzzling that that we have a high, to say an average rating that's towards the top of the distribution. That's this 5. That's actually more common for people who quit the service than those who stayed with it. Okay, so that's the puzzle. Like, what do we think is happening there? This is something that you can take. I took PhD level stats courses, and I certainly didn't learn how to think about this problem and what could be causing it as part of PhD level stats, where we're doing all sorts of integrals. But if you've done a lot of applied data science, this sort of thing can pop out at you pretty quickly. So hopefully you've had a chance to think about it. And what's happening here is that users who continue using the service, those on the left, they have a lot of ratings. And if we weren't careful about how the data was prepared, some of those could be ratings from after the period where we were trying to predict whether they would quit or they would stay. Those on the right, they quit using the service. They frequently have only 1 or 2 ratings. And so it's pretty easy if you have a small number of ratings for those to be at the top or the bottom of the distribution through something which is sort of roughly a law of large numbers phenomenon. Okay, so here's the part that's important. To the extent that this hints that the data may be changed after the thing we want to predict, that is something called target leakage. And I won't go into all the technical detail because we're sort of more focused on something that's a different issue than what is target leakage. But when that occurs, that will cause your model to look very accurate when you test it, but then when you deploy it in practice or when you use it for practical purposes in the future, it will be very inaccurate. This is, like I said, the sort of thing that the short-term focused person who gets a job quickly and works on real data science project, they're going to learn to recognize these patterns. And you can do really high-level statistics or really high-level machine learning education and not learn to spot things like this. And so in that sense, I think it's sort of understandable that companies aren't excited about purely MOOCs or, to be honest, purely PhDs. Or certainly aren't excited about the pure PhD with no practical experience, as many of us would expect. So the thing that we find is when we say short-term SAL has this higher trajectory, in part it's because they get to see these practical issues And as a result, they always have more experience where it matters, always have higher knowledge and higher achievement. Okay, so I, at this point, advocated that the long-term strategy of taking these really long courses doesn't pay off. What should, instead of what should you not do, what should you do? Okay, so the short-term SAL has a strategy. First of all, you need to learn, you're gonna focus on doing hands-on projects. You need to learn the minimum necessary to have a successful project. You know, I mentioned that I run Kaggle Learn. This is something that we're very focused on in Kaggle Learn. Our courses, I showed you these courses, which took a matter of months. Our courses are measured in hours. They are very, very, very applied, very focused on giving you enough to have a successful project in any given area like deep learning. But at the same time, we're not going to teach you everything because we know that it's important for you to start working on hands-on projects quickly. Okay, so you learn the bare minimum necessary for just take on a project. You second, find a topic that's interesting to you. So that could be a hobby, that could be an industry you want to work on. If you can find data about a TV show that you enjoy, if there's a news story you found compelling, whatever you find interesting, try and build a data science project around that and show it widely. So showing it widely means posting about it on a blog, hosting it in Kaggle kernels, posting it on GitHub, tweeting about it, posting it on LinkedIn. I'm telling you to post it broadly, even though I'm also going to tell you it probably is not going to be that good if you're not that experienced, and that is okay. You're going to have one of two responses. Either people will tell you they think it's not that good, and ideally they'll tell you why. When you engage in those conversations about how to improve your work, you're going to learn very, very quickly. And in some cases, it'll be something that you can just change something very quickly, and that'll be easy, a great learning experience. In other cases, you'll realize, like, I don't have the theoretical knowledge to do a great job on this project, but I learned that from my interactions with others. And you may end up taking a short course or looking something up in a textbook. You will learn theory, but you're going to learn it as needed. That's going to make sure that it's theory that's applied. And in practice, like, of the people who I have mentored and who I've talked to, I find, and this is actually also true in my experience, you will find yourself more motivated and you'll find more time to keep working on learning if it's something that you can contextualize in improving a project that you're excited about. So that's what happens if people tell you that they think the project can be improved. The other alternative is you might find people who really, really like the project, and that's obviously an even better outcome. That's a starting point for networking. If you find people who say it's a great project, let them know that you're looking for a job. After someone's complimented you on your project, they may be inclined to try and make connections for you. They may say, oh, we're hiring. And if you go back to that stack of 1,000 resumes, this is how you get to that stack to be either a separate pile, which is only 1 or 2 resumes, or you get to be the top of that pile. So this is really like a really important outcome of publishing your hands-on projects. In most cases, your first project isn't going to land you a job because, it's getting your first job in data science is admittedly at the moment a somewhat challenging thing to do. So you might need to build 2 or 3 projects and iterate until you have a portfolio. Why does this work? So first of all, the skills you acquire are very, very applied, addressing things like this target leakage issue that I mentioned. And then secondly is, so this is something that I learned from a friend who isn't in the field of data science, but who hired a professional career coach. And the career coach gave them lots of advice. One of the pieces of advice which always stuck for me because it was the most surprising piece of advice is something that I'm going to call the yellow scarf technique. This is pretty close to the sneaky technique that the others in the job market don't want you to know. So the idea of the yellow scarf technique is that when my friend, when she went to interviews, she was told to do something, not something offensive or something too outrageous, but something memorable. So you could, for instance, wear a yellow scarf. And that way, when everyone who interviewed you, and at this point, they've probably interviewed 10 different people for a single job, when someone says, hey, I really liked Sal, I thought they did a great job of of explaining their model. Others will say, wait, who's Sal? And if no one can remember who you are, then you sort of get lost in the shuffle. But if someone could say, oh, that's the person who, when they were interviewing, they were wearing a yellow scarf, it's this sort of memory hook that allows people to remember you, makes it easy for them to discuss you. If you crash and burn in the interview, then they'll probably remember you crashed and burned, but who cares? But if you did well, then this is a way for you to stand out and for them to be able to communicate that you did really well. My friend took other advice from their career coach for a couple months, had some interviews, didn't get any job offers, and then started using this yellow scarf technique. And she got 3 job offers, and I think she said 4 interviews in 2 weeks. So it's a very small sample. The data scientists among us prefer larger samples, but I find it compelling, both as an interview technique, but whether it's compelling as an interview technique or not, I think it's clearly the case that, and I've hired people because I thought they did awesome projects and then I would forward their resume to others in my organization. And so I think it is very clearly the case that in a world with 1,000 resumes, if you can have someone browse Reddit and say, this person's work is actually really interesting, that puts you in a totally separate category from someone who spent a year taking MOOCs, even though maybe you spent 10% as much time on it. A really interesting example, which has been widely circulated recently on the internet, is someone was a aspiring data scientist, didn't have a job, but I think had taken some sort of boot camp. They wanted to do a project, didn't have data, so they put their smartphone on the front of a shopping cart and walked around a grocery food store. Took some photos with their smartphone, and then tagged the data to show where the shelves needed to be restocked. So you see that in these red boxes here. They then trained a deep learning model to identify where the spaces that need to be restocked, which, by the way, so I find this an interesting project, and it has this like nice visual to it. But the underlying thing that they're writing about, when to restock grocery store shelves, is in some ways like the least interesting thing that one could do a project on, and yet this still is like ends up being a sort of interesting project. Yeah, and I think if you're creative and if it's novel, that alone is enough to make a project pretty interesting. They were, by the way, contacted by the grocery store that they shot these videos in, proactively contacted, and then hired because the grocery store was so impressed with their work. That's one example of a success, and I certainly know of others, though I think the visual nature of this makes it really quite memorable. Okay, so that's one project someone did, hopefully is inspiration for you. If you're not going to do exactly that, and you should do something new, what are the things that you need for your project to be successful at getting you a job so that you can be on that steep part of the trajectory? So the first is visuals matter. This favors deep learning because deep learning can work with images, and images are intrinsically visual. But if you want to do something that's not using images or not using deep learning, that's totally fine, but you need to make graphs. Having nice graphs is super important. You should make the graphs, if you blog about it, they should be at the top of your blog. If you post it in a notebook on Kaggle, it should be front and center. Your graph should be beautiful and towards the top of your notebook. If you put it on GitHub, so this, by the way, is a separately quite important point. So in GitHub, you can have these files called readme.md. I'll just call it readme. And that's, if someone goes to the homepage for your GitHub project or repository, that's the main thing that takes up most of the screen. It's really important that you have nice looking and clearly communicated README files. That should have a graph at the top, something visual. You will spend hours on your project, and because you spend so much time on it, you think that others will read it in some depth, but that's just not the case. When we look at projects, not only we being me and people who hire, but also probably you tend to scan around, tend to look at it very quickly. So you need to remember, it needs to grab the user in the first, 5 seconds or so. Creativity, like this example using the grocery store, and communicating well are important. One of the hardest parts is finding data. Kaggle has data, And so go to Kaggle, kaggle.com/datasets to find data. All that data is freely available. You don't have to pay for anything. And then lastly, browse for others' work. And don't copy it, but it's really hard to sit in an empty room and just say, okay, be inspired, be inspired, be inspired. That doesn't work. But if you look at what others have done, either you'll say, oh, I kind of like what they did for the sport of football, but I want to apply it for cricket, or I think there's some flaw with their analysis, and I'm going to do some analysis that I think improves on it and start a conversation with them. And so browse others' work for inspiration, because that's one way to just come up with project ideas. Okay, so I have told you something that I have seen a lot of evidence is very successful. I'm extremely confident that it will be successful for those who take it very seriously. And yet, unfortunately, I worry that many people will not pursue this at all. And the reason for this is many people who are trying to get into the field of data science have spent most of their life, in many cases, almost their entire life, as students, studying from textbooks, learning from courses, learning theory. And that's what you're comfortable with, that's what you know. It's a little bit hard to do something that's totally different. Many of you have probably never done a real hands-on project and just published it on the internet outside the scope of a course. And doing something new and unfamiliar is hard. And so many of you, despite the fact that I am confident this will be successful if you pursue it, I know that it's going to be very difficult for many people to make that mindset switch away from being a student. But you need to do it. And if you do it, it will pay off. Okay, so hope we have some good questions, and yeah, interested in hearing them.
All right. Well, Dan, we can pull away your slides there for a moment. We want to see you on our big screen here. And also, you may have been missing it, but in our chat, there's been a lot of discussion on who's on Team Sal and who's on Team Lee. So there's been a lot of back and forth there. So thank you so much for the time that you have here today. We have a number of questions that have been coming in from a lot of different users. So I'm gonna go ahead and kick things off if you don't mind. Let's see, first question that we had that came in was from a Mike Lane. It said, personally, Mike has struggled with the transition from education to business because there seems to be this barrier to entry that's provided by technical jargon, tools, technology, and platforms. So what advice would you have for educators who want to go into data analytics and transitioning into business if they feel like all of their skill sets or all their knowledge may be only what they've learned in the classroom?
Yeah, I mean, unfortunately, this is something that varies on a case-by-case basis. There's some jargon, so there's both on a case-by-case basis due to where they're coming from. There are various types of educators, people who are teaching math or people who are teaching English, and those are quite different from each other, people teaching programming. And those are indeed quite different from business. And that's part of that is you know, short-term Sal, once Sal gets that job, is able to have that steep learning curve in part because of learning the business piece. I'm gonna go back to what I said earlier, which is you need to create something that you can share that people will find interesting, which is on a topic that someone can care about. And someone can care about could be restocking shelves. It could be, so gosh, an example that I saw recently was picking which character was gonna die in Game of Thrones. So that's like, by interesting, it doesn't need to be that business-like, but you will find people who like Game of Thrones and also have jobs. And you want to engage with those people, tell them, hey, I'm on the job market, and hope that those people will and go, for that matter, go to, as mentioned, publishing online, but you should also go to meetups and try and present your work as a way to build that connection to people locally. And if they say, I liked your analysis, I found it super interesting, they very likely will help you find a job in your area. So I've said you need to make a project, but even to make a project requires that you make a shift in technology. So if you've never programmed in Python or R before, then you're not ready to write your first project. I personally am quite partial to Kaggle Learn. I think that we have the best approach. We indisputably have the fastest way for you to learn enough to start doing projects. So I would say the Kaggle Learn course on Python if you haven't programmed in Python before, but then our intro machine learning course. We have a bunch of other courses, honestly, for now, or maybe you could skip machine learning. And if you want to do data visualization, we have an intro data visualization course, but skip the rest of our courses for now. Honestly, that could all be done. Those 2 courses could be done in a weekend or a day and a half, probably. And then find a topic that is interesting to you, and then go through this workflow that I described. You will not learn all the business jargon, but you will learn enough to impress people, and they will be happy to teach you the business jargon once you've shown that you can do interesting data analysis.
It's a great answer, and it reminded me, and I mentioned this in an earlier session, that as a part of our CareerCon, we have a session coming up on how to create your personal brand, even if you don't like self-promotion. And so be sure to stay tuned into that. I think that would be really a great one for you. Dan, that did kind of bring up another question that came in. This one's from Sandeep Singh, and said, in addition to ML, DL, and AI techniques, it seems mandatory to learn LeetCode, HackerRank sort of programming skills. So they're feeling that this lack of skills is a blocker, and the only criterion to hire here, specifically in Silicon Valley. From their understanding, ML and DS learnings are not even asked about in Google and Amazon interviews. Do you agree that programming skills are required to get a job in ML?
Yeah, this is a great question. It varies a ton from employer to employer. So that is almost certainly true. So there may be exceptions, but that is at least 95% true at Google. So when we talk about LeetCode, I'm just going to describe that as algorithms. Google interviews always involve a good deal of focus on algorithms. It varies a little bit from one Google interview. When I did my Google interview, there was probably a little bit less on algorithms because I was coming as a data science educator. But by and large, yeah, Google interviews involve a ton of algorithms, and there's a shift, certainly in Silicon Valley and probably in most of the world, towards more. The businesses are realizing that they need more and more machine learning engineers and less of pure data scientists, where you're doing just what we've described as ML or deep learning. Despite that, I think there's also a huge market for traditional data science, which is not as focused on algorithms. I worked at a company called DataRobot, which built an automatic machine learning tool or a software for data scientists. The vast majority of our hiring was for conventional data scientists, and we asked no algorithms questions. Time spent on LeetCode would be totally irrelevant for our interviews. So it does vary on the employer. Anyone who calls it an ML engineer is going to be looking for some algorithms knowledge. But there are a lot of analysts and data science jobs where you will not be asked those questions. And unfortunately, Sandeep brought up Google and Amazon. I would say those are outliers in the extent to which they focus on algorithms.
Okay. We're actually getting a number of questions that are coming in on somewhat of a similar topic. And I'll read through a couple of them and you'll kind of see the theme that's coming in here. Walter Santos said that the single most important question he has is, in terms of skills, generalist or specialist? And we know the answer probably depends, but still want to sort of open up a discussion on that. The next question that sort of came up related to that was, that many job ads ask for a generic quantitative background, and then continue by specifying that they would like someone who's extremely well-versed in every conceivable area of ML, advanced probability, PhD level stats, Python and R. How do you sort of learn enough to apply for these positions without trying to be everything to everyone? And then a final one came from Ketov23. How do you find the balance between quality, how deep you learn something, and amount, how many to learn? So a lot of questions sort of on the breadth and the width. Do you want to talk about that a little bit?
Yeah. So you will frequently hear the advice, which I think is good advice, to have a T-shaped skill set. So the shape of a T, I guess you probably have to turn it upside down for this graph to really work. But if you imagine a capital T, you flip it upside down, then the base is pretty wide. You have some very basic skills in a wide range of technologies, but you have one thing that you are truly specialized in. So it is totally fine if you don't know a lot of probability. If someone asks you about the Poisson distribution, say, I'm sorry, I've focused on machine learning and don't know a lot of probability. It is okay if you cannot, if you can write some Python, but you cannot use decorators, or maybe even like you're not that good at, you've done almost no object-oriented programming, like that's okay for, well, by object-oriented programming, I mean like you've never written a Python class. I'm confident that, I don't recall the specific example, but I'm confident that I've been involved in the hiring of plenty of people who have not written Python classes for data science jobs, but they did know enough Python to get by, to do something productive. And so you need to know some Python or some R. You certainly need to know like mean, median, a little bit of percentiles. So you need to know basic statistics. It'd be good if machine learning is not your specialty, you still need to know the idea of validation and should be able to describe what overfitting is. And then you should have one thing that you're quite good at. And to go back to my emphasis on projects, that should be the thing that you focus your projects on. And that it could be data visualization. And you could know very little about machine learning, but know enough to talk to someone about machine learning.
So actually, two questions that we have listed for you that were based off that. One is on the latter part where you said, talking about projects, would you recommend to people who are still trying to get into it, should you take a technique that you want to learn and then find projects that can help you learn that technique, or take a subject that you're passionate about and then find projects to then learn about that subject you're passionate about?
Yeah. Okay, so when we talk about technique,
sorry, that question came in from, I want to make sure I give them some credit, from Purba Hulgal. Correct, yeah. Possible research problems in your area of interest or technologies you want to go explore.
Okay, so when we talk about technologies, we can talk about them being sort of broadly. So a technology is deep learning. Or we could talk about them quite narrowly. So a narrower version of deep learning would be, I'm interested in LSTM networks. So that's a type of deep learning model. I think it is great to say, I'm interested in learning a certain data visualization tool, or I'm interested in deep learning. And at that level of generality, say, I'm going to do something that works with images using deep learning. But then I'm going to find the projects that I can make sure I'm doing something that is interesting to me and will be interesting to others. And I'm going to let the fact that I want to work with images steer me a little bit. But then within that, I'm trying to find an interesting project. I think it's a mistake to say I'm focused on LSTMs, or I'm focused on XGBoost, and I'm going to use like exactly that narrow technology and shoehorn whatever topic I have into it.
Right.
And to be honest, so let's say that you do this. Which characters are going to die on the Game of Thrones TV show? The actual accuracy of your model doesn't matter a ton. Like if it's a reasonable model and you communicate about it well, it doesn't matter whether you used it XGBoost or Random Forest or whatever else. And so in a narrow sense, I think some people get tempted to focus too much on the narrow choice of technique, but it's great to think about what type of data science, broadly speaking, do I want to learn and do I want to do?
That's a great answer. And one of the other ones that came up that was specific to the comment that you're asking about, sort of how do you balance the T graph of skill sets. This is from Edmund Nimsing. Said, hey Dan, I should learn DL and ML concepts using Kaggle Learn. And he uses SQL on the job as a financial analyst and does some more learning on the side. With a couple of public projects implementing machine learning and DL end-to-end under its belt, it finds a lot of openings require skills it doesn't possess, like Spark, etc., or preferred advanced degrees, no master's, no PhD, only a bachelor in economics. So at what point should somebody just stop developing skills and just start applying?
Yeah, let me answer that question, but before I do, go back to a part of the previous question, which was that I didn't answer, which was, what do I do about the fact that, because these are related, what do I do about the fact that job descriptions say that you need to have 4 PhDs and 10 years of Spark experience and 20 years of TensorFlow experience? That you need to accept that. So my PhD was in economics, and I am always sort of intrigued by how businesses work and what are the puzzles in that. It's a puzzle to me that job descriptions are so bad, but job descriptions are so bad they are typically written by someone in HR who may not even know what all these terms mean. And so, yeah, there's this barrier of, as long as screening is being done by HR, and who does the first round of screening varies from one organization to the next, but in some cases it is done by HR. It's actually it's a real problem that HR does these screenings isn't qualified to evaluate or even know whether the criteria are reasonable. But you really need to skip that screen. You need to just avoid the screening of I
guess it is, don't filter yourself out because an application looks like it's
do not filter yourself out, but also know that we get so many applications for every job opening that if you apply through the regular channels, your odds are just not that good. So I may say it differently. I would speculate that for every application that comes in through like a shotgun approach of just, I'm going to send applications through the website, for every one of those, for everything that I find because it's an interesting project and someone forwarded to me, they thought I might be interested in it. For every one of those, I get, I think there are probably 200 resumes that go through like the main channel. And yet the number of hirings that happen through the main channel is probably about the same. So if you're going through the main channel, your odds are just not that good. But also you should, if you have a mutual connection, so LinkedIn has this nice feature of a mutual connection. If you have a mutual connection who could introduce you to someone for a job, but you don't have all the criteria in the job description, don't worry about it. Job descriptions are terrible. Yeah. And some of the most successful, I know a couple of very, very successful data scientists who don't have who dropped out of college. Literally, I could tell you names and they've been super successul. So don't let
session tomorrow as well that kind of highlights that, talking about how do you get that first interview if you don't have any connections. So we have a great session talking about that tomorrow on getting noticed, which is great. Prananth actually asked pretty much the exact same question. Do the companies actually get people with all the skills mentioned, or they typically have to compromise and recruit people as well? Two final questions for you as we conclude with our time, both getting to our short-term Sal and long-term Lee. And I'm interested once we log off to see what the current voting is on our poll of who is who. One was from Ravi. Ravi was saying, how do those without a strong signal, for example, without a STEM undergrad degree, of rigorous mathematical maturity prove to employers that they still have the theoretical chops to do the job? So for example, how would short-term Sal deal with the conundrum? Because it seems like the projects that help with the doing part of data science, but do you have any suggestions for crafting projects that demonstrate theoretical know-how that also resonates with employers?
Yeah. So first of all, I'm gonna answer that question. But first, let me say I think many people in the community overestimate the fraction of data scientists who are doing mathematically difficult or interesting things, and instead a lot of it is sort of day-to-day application data analysis. Going back to like that graph, noticing that this data was probably collected for one of these groups after the fact. Okay, but if you are truly, really do have great mathematical skill, some of the ways to show that or emphasize that. One is, let me give you some example projects that immediately come to mind. And you don't need to exactly, but these are hopefully inspiration. So in deep learning models, there are a number of ways that when we set up the model, that we can initialize weights. And if you don't know what this means, you can look it up. But anyway, there are a bunch of weights that go into a deep learning model. There are a bunch of ways that we can initialize them using different statistical distributions, and under different circumstances, some of those initializations work better than others. It's not super well understood why that's the case, and at least last time I did any research, it was not well understood. If you were to do this, this is not that relevant for most day-to-day work for most data scientists, but it is something that is a mathematically challenging question to understand. And I think it would be a really interesting project for someone to explore. If someone wrote something up about it and did a reasonable job, I would find it super. If you do that, send it to me. If I think you did a reasonable job, I will retweet. I am so intrigued by that particular question. I will retweet it. I will repost it on LinkedIn. I'll say, hey, everyone I know, like this is actually like an interesting problem, and someone made some progress on that. So you could do something that is widely recommended, but I tend to think is kind of boring, is just re-implementing an algorithm that exists in a standard library like scikit-learn. But that requires not a ton of math, not a ton of hard mathematics, but a little bit of mathematics and more programming. But you can do a theory project. I think for most people, that's a red herring and a mistake to do something that's that theoretical and not applied. But those would be my first thoughts is understand, or look at for different loss functions, compare how they do in some real applications, and then try and explain the mathematics about why they behave as they do.
Okay, I think it's great. And then one more of those, I'm gonna leave that to the Slack channel, but a final question for you. I'm trying to ask a lot of our speakers the same question. What's a question that you weren't asked that you should have been asked?
So I have been involved with a lot of different mechanisms by which people learn data analysis. So I immediately after my PhD, I briefly taught at a university, and during my PhD I taught at a university. I taught a boot camp. I've run MOOCs, so I've seen a lot of the different ways that that people learn. And so one of the questions which I think is an interesting one is, for a lot of people, is what are the benefits of each of these approaches? I've become quite disenchanted with the academic path. One, it just takes a long time and it can be expensive, and it can build projects because their data science programs are catching on that's important. They're frequently taught by people who have a nice theoretical background but no industry or applied experience. So I think that is not a great approach. Boot camps, I think, they're widely criticized because all this material is available online for free. I think that's the wrong way to think about it. If it means that at the end of 12 weeks, you get a job that pays whatever, $100,000 a year, and like you can do that with reasonably high certainty, like that clearly is worth whatever you paid to get into the boot camp. I shouldn't say that. In my opinion, that's almost always worthwhile. The problem that they have is quality control. So I've gone to see the presentations from a specific boot camp, which is local to me, and sometimes they do end of course presentations, and they're all awesome. I would hire 2/3 of them, and then other times they're all pretty embarrassing. And so, if you're going to go into a boot camp, you really need to figure out who's going to be your teacher. Try and get reviews not for that organization, but for that teacher specifically, because quality control is an issue. MOOCs, they're free. The hard part is finding the discipline. If you end up going with one of the routes that has long courses, finding the discipline to stick with it and then make sure that you apply it and aren't just learning pointless theory.
I know that's been a personal concern of mine, trying to stick with it as well as I'm learning my own No nuns there. Dan, thank you so much for your time. Been incredibly helpful. What a great way for us to wrap up our first day of Kaggle CareerCon. I want to note for those of you who are watching as well, if you are a part of the Kaggle Slack channel, we know that there's been a lot of issues trying to get connected. Frankly, we have to send out more and more links because so many thousands and thousands of you are signing up that we have to refresh that link every time we reach a certain limit. So please be patient with us. We'll be posting those as we get those updated. But Dan, again, thank you so much. Dan said that he'll be checking in over the course of the next few days, trying to answer a few additional questions that you may have. So continue asking those in Slack. Dan, thanks so much for now. We appreciate it.
Thanks so much.
To everybody else who is still on the call, finally concluding our day here is going to be our day one Slack mixer for job searchers. Not to be confused with our career and education fair that's happening on day 3, but this is basically your chance to get to know other attendees a little bit more, connect over common job search struggles, whether it be in your country or specific area of interest or an industry that you want to pursue further, and maybe even a chance to team up for future projects. So our CareerCon Slack community manager is Paul Mooney. Probably seen him throughout the Slack channel. He's going to grant everyone the ability to create their own interest-based or location-based channel, like hashtag Boulder, Colorado for me and Dan, for example, or hashtag bootcamp grads, or hashtag biotech, or any variety of interests or locations or things that can connect you together as a part of that mixer. And we're actually going to be awarding prizes to the channel creators with the most members. So we're going to conclude our day with that. Again, check out the job mixer that is happening, the job searcher mixer happening in Slack. We're excited to see what you come up with as you continue to meet each other and share your experiences. And as we sign off for today, you will see the schedule come up for day 2. We'll be kicking off things again tomorrow, right at 9 o'clock Pacific time, with our second API workshop with Rachel Tapman. And until then, thanks so much for tuning in. We'll see you guys tomorrow.